We're going to get started here, everybody. We're a few minutes early. Sorry to cut it off. We may have a little break here in a bit. But hey, thank you for coming. Welcome to IntelliTect. This is one of our new spaces that we're kind of working on, experimenting with this basement that we had and trying to turn into something more than just a place to park vehicles. So anyway, welcome. I'm glad to have you here. Glad you made it through our little bit of a rabbit warren. It used to be way worse. You had to walk over here and around a bunch of other stuff. So we made a new stairway just for you all. So anyway, my name's Grant. I'm the CEO here at IntelliTect, and we have a number of our folks here. There's not actually too many of our folks here, but what I wanted to do was just take a couple minutes. I want us to go around. We have a couple extra minutes, and I want you to answer 3 questions. First question is your name and where you're from, if it's a company or a location or whatever that is, and then what your favorite. Well, you don't have to answer this, but your favorite model, AI model. And yeah, that could have gone a lot of different ways. I did not think about that. Brad Pitt, no, that's not a model. But and then what you if you like to do something with that model, hey, I like to experiment with this. I think that'd be cool, and maybe be a nice way to find some connection between some of the people here, because one of our hopes is that hopefully you go away with a whole bunch more information that you can take back to whatever you're doing and be more productive in what your particular job is. But second of all, we hope to get connected with the community of software developers here in the Inland Northwest. And you have to use the word Inland Northwest because who is not from the state of Washington? We have a few. Or, okay, who is not from the state of Idaho? Okay, so people travel. Hold it, but you didn't raise your hand when you weren't from. Oh, sorry, I asked that wrong. Oh yeah, who is outside of Washington and Oregon? Oh, gosh, I can't even say it. Who is not from? Forget it. We have a guy from Montana here, so if you beat him. So anyway, he drove in from Kalispell this morning, so we're glad to have Corey here joining us too. So anyway, I'll talk to you about some of the stuff that I'm doing. So my name's Grant. I work here at IntelliTect. I used to develop software. I really like to do that, but they don't let me do it anymore. So at home, my current favorite is Claude Opus 4.5. I'm using up all of Phil's Azure credits to burn through tokens. And I've just been having a super fun time building apps. And I built out a Next.js thing, and I'm just having it build little apps for me to kind of learn what is it really good at. And so I've started with some Coalesce apps now, and it's doing actually a much better than expected job building some of that stuff. So pretty cool. So let's start. We'll start with Kevin over here. Here, we'll just hand the mic around.
Kevin Boss here from IntelliTect. I don't know, Claude Sonnet 4.5 because I don't have the 3x spend that Grant does, I guess. And I mean, most recently, I enjoy using it for automating filling out my timesheet because I'm way too lazy to do that.
Hi, I'm Samantha. I'm from Coeur d'Alene, and I don't have a favorite model just yet. I'm still deciding. Yeah.
I'm Shane. Come here from Avista today. I do some video and some AI stuff, but I still think Sonnet 4.5 is my favorite. I use Opus, but I'm also of the cheapest kind, so I only have 300 premium requests per month. I'm not going to burn them all.
Shane makes a lot of really cool videos online of like music videos and stuff. So if you're interested in that, Shane has cool stuff.
I'm Gary. I used to develop software regularly for the Army. I've been playing with Grok a little bit.
Nice. Yeah, let's go across. Sure.
I'm Sam. My favorite model is Gemini 3. And I'm from Bellingham, Washington. I moved here recently, but I was worked for Raptalis Financial Consultants on their software team, building out websites.
I'm Alex. I'm from the area. I work at Itron. I guess my favorite model right now, we'll say Gemini, and I ask important questions like how to center a div, I guess.
Opus 4.5, and I asked how much 4 times, and then I asked a different model, and I got it the first time.
My name is Josh. I'm also from the area. Itron as well, but I'm only an intern. And probably Sonnet 4.5. That's what I use the most. So what I do with it, anything, home server stuff, I don't know.
And there's a few people here. We're teaching a class out of Eastern, so there's a few folks there, and he's our TA and doing an awesome job with that. I tell him to do stuff, and then he types the right things. That's great.
Hi, I'm Will. I'm from that class at Eastern. My favorite model's probably ChatGPT 5. I like to get it to pretend to be a character.
I'm Melissa, and I'm a recent software engineering graduate, and so I'm looking to get into the tech space and just dabble in Copilot right now mostly, so looking to explore it more and excited for today.
My name is Paul Kersaba. I'm with Hackathon Tech in Coeur d'Alene, and my favorite model is ChatGPT 5. I use it for a geospatial project.
I'm Chris Finlayson. I'm from here in IntelliTect. I use Cloud Opus. Lately, I've been using it a lot for helping with database performance issues.
I'm Megan Nelson. I'm from Hackathon Technologies. I'm not a developer, so I don't use models, but if I need someone to help me clap back to my boss, I use ChatGPT professionally.
So by the way, there's a, you mind if I just pitch you for a second? Yeah, that's fine. So the team is working on a product called TicketGo, which is essentially a competitor to the big evil empire of Ticketmaster. And it's a really cost-effective, so if you are looking to do any kind of ticketing thing, it's a very reasonable price. Feel free to reach out to the team over there, go to their website.
Yes, absolutely.
It's
or
great.
if you own a golf course, we have
golf software too.
Michaela's done a wonderful job on it.
Anybody own a golf course? Because Phil's going there after me.
I'm Wendy Corbin. I'm the business development person here at IntelliTect, and like Megan, I use ChatGPT 5 to help me do my job better. So.
I'm Austin, and I'm from Spokane, and I'm working at Safeguard Equipment currently. And my favorite model is, I like Grok Code Fast for a lot of reading through legacy code bases because it's just fast. It's sometimes inaccurate, but I like to tell it, hey, how does this work? And it's pretty good at that.
My name's Brian, also from IntelliTect here. I guess I would use Claude Sonnet 4.5. I'm currently making it build a application from the ground up, and it's doing all the work for me. So, yay! It is. Oh yeah, I've been very impressed with most things.
Yeah, there's been a huge jump in the last 6 months.
Yes.
It is very productive stuff.
Yeah. Sometimes the frustration is it'll do a thing really well, and then you'll have it build something else that's very similar, and it'll go off on a tangent. You're like, no, do the thing like you did 15 minutes ago. Oh, I see. The user is frustrated and wants me to do.
I'm Ben Michaelis, and I work here at IntelliTect. I primarily probably use, it depends what part of the month we're in and how many requests we got left, but early on I'm using a lot of Opus lately, and then once I run out of minutes, I'm probably down to like GPT Mini, but that's not by choice, so.
Corey Cameranen, Director of Engineering at Water Street Company out of Kalispell, Montana. I use Cloud Sonnet most of the time, but sometimes I use Opus when we got the credits, primarily for like memory dump analysis, attaching debugger, letting it do that, or email refinement, investigate things for me.
Hi, I'm Ethan. I'm from the class at EWU, and I guess I would say probably ChatGPT. I use it to organize because I have pretty bad ADHD, so it helps there.
I'm Michaela Croskery. I work at IntelliTect. Favorite model right now is probably Sonnet. It works great for telling me what all the Ruby on Rails code that I'm supposed to convert actually does, and then I redo it.
My name's Corbin. I'm from the area, and I'm still trying to find my favorite model.
I'm Gina. I'm from Columbia Bank. I'm a quality assurance engineer. Quality assurance engineer. Yeah. Don't really have a favorite model. Mostly poke at them to see how they don't work.
My name is Jonathan. I also work at Columbia Bank. I'm up in Sandpoint, Idaho. And my current favorite model is Claude Sonnet 4.5. I use it for rapid prototyping of proof of concepts.
Phil Spokas, CTO at IntelliTect, and you're like asking me to name my favorite child. I can't do that. GPT to make statements of work and other related stuff. So.
Just hold tight for a second. So I want you to look back past Phil. This is Lindsay. She has put all this stuff together. Would you give Lindsay a hand?
Okay, I'm the operations manager here at IntelliTect. I'm Lindsay, that Grant said. And I'm not a developer, but I use ChatGPT 5 every day, all the time.
Hi, I'm Kate. I'm an Eastern student, probably GPT-5 because that's what I can afford. And I have done some projects with agent-to-agent flows.
I'm Colton. I'm a student at EWU. My favorite model is also GPT-5 because it's free and I can use it to write emails and help me code.
Hi, I'm Peter. I moved here from the South a couple years back, and I use all of them. I find productivity in all of them, but Grok is the funniest to me. So.
My name is Seth. I'm from the Master's Touch. We send you your property taxes. You're welcome. I just use whatever Copilot gives me, so it's all used to be GTP4, now it's GTP5. And pretty much I don't search the web anymore. I just ask Copilot why to waste my time with search results.
So let me just ask a question. How many people are, when you search the web, or maybe aren't searching the web, you're really going to those AI results first? It may not be the only thing, but who's using the AI results first? Who is not using the AI results first? Hey, I'm going down, and I'm looking at the actual content. Okay. Totally.
I'm Aaron Ney from STCU as a principal developer there on the DevOps team, and I'm kind of in the same boat. I mostly use VS Code, Copilot, and I use it outside of work for like planning trips or trying to figure out which next electric vehicle I want to buy. So what's what answer? Oh, well, okay. Once you get the wife involved, it changes. So, yeah, that was my choice. She chose Tesla Model Y, so I think it's going to end up that way.
Brandon, I'm also a developer at STCU. I'd say I use ChatGPT and Copilot because they're free and available. And I mostly use it for making models from one language to another.
Let's see, Paul Ernsdorf. Currently, everyday use Copilot just because the way it's integrated and it works well, and I do all the searching and everything. But Claude, latest Claude for actually doing hardware, experimenting with some hardware stuff. So, yeah. But.
Like you said, I'm Dan. I'm an engineer here at IntelliTech. I find Opus 4.5 the best for like planning steps and architecting, but then I generally use Sonnet because of tokens. It's cheap.
Exactly. Well, hey, thanks everybody. I thought that was really interesting just to hear how people are using different things. So this app that you're looking at here is one that I literally, this is what we do for our class. And so I was prepping over the break, and this is 100% generated by AI. And even down to the point where it knows how to, like, you can have hints, and it'll guess. This is kind of the self-looking ice cream cone. But it tells you, oh, there's only one more possible word. Boom. And it takes keyboard input. And this is probably 20 or so prompts. But there's all kinds of really little interesting things. This is probably 5 or probably 8 prompts to do stuff like this. It is absolutely amazing what is possible with AI now. And I think it is really changing the world that we're living in. And while we're not talking about that specifically, I don't know if we have any, we're not going to do a whole bunch of this stuff, but I think the place where we are is super interesting. And I like the comment somebody said, AI is not going to take your job. Someone using AI will take your job. And so I think for all of us, learning how to use the tools that we have, just like people that were programming, well, actually people that program in COBOL might be okay now, but for a while, you know, you're learning the new things. And just like we all know is that we've chosen a field, unlike laying bricks, where you lay bricks basically the same way now that you did 100 years ago, the way that we're even doing code and the way that and it's accelerating even faster. And so kudos for being here and wanting to lean ahead into what is coming. Because the world that we're in is changing fast. And it's really exciting because what it means is that things that used to be impossible or very cost prohibitive are now becoming possible, and they're having returns on investment that we've never seen before. And so the potential for human creativity in the space of computer science-y stuff, I should obviously take this off the screen, because isn't it mesmerizing a little bit? Is really incredible. And I'm excited about what it means for us as practitioners. And I'm excited about the kind of community that I'm seeing develop here and in other things that we do. We do a number of things like this. And just seeing people come together, share ideas, and trying to help not only our peers, but the next generation, people that are coming up, all that kind of stuff. So let me give a few little details. Let me close down my little thing here. You can go check out that repo if you want to. The structure of today is going to be, we're going to do some somewhere between, each session will be between 2 and 3 hours. They'll be back to back, no breaks. Sounds awesome. It's good. Okay, Shane's in. Actually, there's going to be, we'll have about 2 45-minute sessions. We're going to have a break, and then we'll do another set of a couple of sessions on that. We're going to start out, so bathrooms are literally right behind this wall, right behind this very well insulated wall. Just in case you're wondering, it's very well insulated. Any other questions? There's more food in the back. There's beverages back there. Am I missing anything? Any questions? If you can do escape, right out the back. It's pretty easy. Okay, well, without further ado, I would like to introduce Microsoft MVP. And all around pretty good guy and super smart. Kevin has had probably a larger impact on more developers here at IntelliTect than any other person because of his ability to help other folks in a way that people can really understand and grab onto. When you work with Kevin, you feel like you can do it. And I think that's an amazing thing. People that are super smart oftentimes make you feel like you can't. You get done talking to him, it's like, yeah, I'll never figure that out. But when you get done talking to Kevin, you feel like, wow, I could do that too. And I think that's one of the amazing things about our first presenter, who's going to talk about .NET Aspire, Kevin Boss.
Thank you, Grant. Welcome, everyone. Stokes, if you want my chair, you can have it. Cool. So I was going to go through and drop into .NET Aspire, just to kind of get everybody caught up in case you are unaware of what it is. Most of the apps that we build today are not just single little exes that we run, right? Applications are built up of multiple parts. There's often databases. You've got a front end, a back end. And getting those things built, debugged, deployed, requires a bit of complexity. Aspire came along as a way of trying to simplify that whole process, being able to say, okay, this is my application as a whole. How am I going to actually build, debug, deploy, and run this? Because the bigger your application gets, the more components that get added on there, the more difficult it is when somebody comes onto the team and says, hey, what can I work on? It's like, well, okay, to get this set up, I need you to walk through this README, follow the following script, make sure you download this backpack file from the staging database, reload it into your database. That'll get you the appropriate seed data. If that sounds familiar to you, that's because we've done a lot of this over and over and over. And so Aspire aims to bring all of that down into a simplified way to be able to manage our applications. So I've got a link there if people want to pull some of the stuff that I am showing. I think if all goes well, I've got 3 key lines, and we'll point them out. So for Aspire, it's somewhat difficult to define when people say .NET Aspire, and the easiest one that I can come up with is it is a code-first tool chain to be able to go through and manage your application. And what I mean by code-first is Aspire is built in .NET, but it is not necessarily only for .NET. You can have your front end in React. You can be using Python and a Flask app as your back end if that's what you want to do. The Aspire tooling just gives you that extra orchestration layer to be able to stand up your infrastructure, to be able to manage all of that. It brings things together like local orchestration. So the idea of somebody comes onto a team, you need to stand up this application. Maybe things can run locally. You can have Docker containers for doing a lot. You can put your database there or otherwise. But maybe you have cloud-based resources. You've got an AI Foundry instance that your application needs to run. Yes, you can run Foundry local, but maybe you actually want your developers leveraging a cloud-based Foundry model because your developers may not all have massive development machines that they're working on. Having something that says, well, how do I stand up that cloud instance? How do I then appropriately grab that connection string and inject it into the right place into my application? Most of the time, for a lot of us, this is a README. If we've gotten really fancy, people have scripted it. Aspire gets it down to, I'm going to codify that so that I can clone my repo, F5 run, and all of that stuff gets built out and runs for me. It also gets us down into this nice bit of simplified debugging and flexibility. Because the problem with all of this kind of fancy orchestration is what's great for me is probably not what you're doing or what you're doing or what you're doing. Everyone's got slightly a different flavor. Every client we go into at IntelliTect, like there's some common themes, but everybody has their own way of this is how we structure applications. No, of course not. We don't let people run Cosmos DB locally. We always put that in the cloud. Oh, no, of course not. We always put our databases local because we want developers to have their own containers, right? All of those types of things. There's different flavors of how people do it, and Aspire gives you that flexibility to decide what should yours look like and be able to go through and build out. And with that, I am done with slides because we can talk about it all day. So if people are interested, QR code will be up later as well. But we are going to drop in. So we're going to actually go backwards, and I'm going to tempt the demo gods and see how well, oh, it launched. Hallelujah. OK, so my demo, I'm actually going to go through and run as well as show it to you. So I have a template that I went .NET new on. And then I used the Azure CLI and said, OK, AZD init, AZD up. 3 command lines, and I went from empty folder all the way up to cloud deployed application, and we're running. In theory, this thing works by saying, OK, we're going to have some Q&A rooms, and I will enter my name. I will be Kevin today because that's what I am. What is the best programming language? And why is it C#, obviously, right? We submit it, it comes through. Somebody on the back end can go through and look at this and approve it. We can see there's a little bit of rate limiting on there to hopefully prevent too much abuse. We can go through and approve it and see, okay, we've got questions coming in here of where things are going to be. We can take these approved ones, go ahead and say, hey, let's set that as current, just so that we can go through and show it. If we had a fancy screen to go through and put it, we can have a separate window over here. Just as a very simplistic way, we can just dump this over here for now. And then we can say, yeah, let's go ahead and clear it, and we'll go ahead and mark that as done and answered. Great. So in theory, if people have questions, we've got a full QA system set up and ready to rock and roll, and it actually kind of works. But then the question is, how did we actually go through and build this? So the proof is in the pudding. And so obviously, we're going to start there. And just to prove it, empty directory. OK? .NET new. Dang it. Thank you, Dan. I probably should. So we're going to go ahead and stand up a brand new template. And then for people who haven't seen it before, AZD is the Azure Developer CLI. So this CLI is designed to go through and make your development process interacting with Azure easier. Insert other cloud providers here. We're a Microsoft shop. I'm a Microsoft MVP, so I'm obliged to show Azure. This is going to go through, scan my current directory, figure out what kind of application I am, and then it's going to say, hey, do you want to actually set the config to be able to deploy this? I am already logged in with my Microsoft account, so it will have the appropriate thing. Puddin sounds great. I think that's appropriate. So it has scanned it. It has made some YAML files. It now is ready with all of my infrastructure for my local orchestration. I want to emphasize something here. This is local orchestration, meaning this is for an individual developer building and deploying on this application, right? I have some reason why I need to actually deploy this into my own Azure subscription. This isn't my stage prod environment. This is my deployment for me personally. And what we'll see is that the names of the Azure resources that get deployed out, they get this hash put onto the end of them. And that's intentional because there's a lot of Azure resources out there that have to be globally unique, right? If somebody else happens to stand up a storage account with the same name as me, well, guess what? Last guy in says, sorry, no, these things have URLs tied to them. We can't have two people anywhere in the world with the same name. So that's the point of the hash to be able to go through and do it. And then AZD up. And then we will come back and check on this in a moment because that is going to spin a SQL server, a bunch of Azure identities, a container app environment, and that unfortunately is a full Kubernetes cluster, and that's going to take it a moment. So we'll let it do here, and I believe it should prompt me for a location of where to deploy. West US sounds great since that's nice and close, and then we'll go through and it will figure itself out and say, yeah, sure, I got you. And then we are off deploying. So resource group is out, and it is out there and going. OK, so let's start breaking down the bits of an Aspire-based application. So if you were to go through and leverage the .NET templates for Aspire, you will find that when you go through and run it, you end up with a couple extra projects beyond what you actually asked to go through and create. The two key ones here are the service defaults project and the app host. The service defaults are Microsoft's somewhat opinionated best practices, and they are designed to be a starting point. They aren't designed to be the end all. It's Microsoft finally taking a bit of a stand and saying, OK, this is really the way you should go through and do. A lot of Microsoft templates, they try to be all things to all people, and so they don't take very firm opinions because it's like, well, sure, you could do it this way. You could do it this way. You could do it this way, which is fine until you have somebody going, I don't know what I'm doing. Where should I start? Right? This is Microsoft going, OK, if you aren't sure where to start, this is a good starting point. But the service defaults project, once it's generated, it's done. That's your code. You can change it. Beat it into submission, make modifications to it, pick what you would like it to be. If we take a look inside of it, a lot of these files are going to be adding in things that you might kind of expect in a cloud-based application. We're going to have things like health checks, because when we deploy out our application, we need to know when it's healthy so that it can be pulled in and out of load balancers or otherwise. Right? We want service discovery, so that we aren't going through and hard coding the connections between two different things. I don't want API 1 having to know a direct address of API 2. I want it to actually just say, hey, I'm talking to API 2, where's that endpoint? Right? Have it actually flow through. Being able to configure out the HTTP client defaults, because when you're making API calls, you want basic resiliency, right? Network happens. Things go down. Things don't work. Having all of those things all built and bundled in place. Same with things like telemetry. I'm skimming over a lot of this stuff because for the most part, this is something, if you are interested in the details, feel free to go through and look and read. But again, this is your code to manage and run. If you are questioning, is this the right way for me to start your application? Yeah, this is a good starting point as far as where to go. And most of what I have in here is basically the default. The only big change that I made is I like application insights, so we'll turn that on too. But again, if you're using something else to monitor, you can change that up as you see fit. The other key part here is the Aspire app host. So I'm going to go ahead and hit F5, and you'll note I am playing in a slightly different folder than the one that I just applied my template into, because I didn't want to tempt the demo gods that much. I was limiting where I wanted to go, plus I wanted to be able to tie my DNS to this one's deployment rather than going through and doing it. When you F5 on a Aspire-based application, specifically setting your application host as your startup project, right? If you have an application where you've got, say, multiple backends and a front end, oftentimes people are familiar with multi-project startups where I'm going to go through, I'm going to start my backend, I'm going to fire up my Vite server, I'm going to get all of those pieces connected. Aspire handles that for you. This dashboard is not just a multi-project startup. There's a process behind the scenes called DCP that's actually watching your resources, and it will intelligently know based upon the dependencies between your resources. So if you say, hey, my backend is dependent on my database, well, it's going to make sure that your database starts and is running as in a healthy state before it fires up your backend. If you just do a multi-project startup, it sends all the things, right? And it's kind of on you to make sure, hey, yeah, I know the back end fails, but that's because the database is still warming up, right? Those problems kind of start to go away once you have this kind of orchestration going in place. You'll note I've got a bunch of resources kind of tied in here, just as, we'll make it bigger, just to give a brief summary. There's kind of only 3 big things here. My app in question is a Blazor front end, so my back end and front end are one little thing. I've got my WebAssembly hosted out of the same app, so there really only is kind of one piece there. But I do also have a SQL database, and you'll also notice that I have this docs in here. I went through and configured out my template to be able to have these things in because I found myself constantly going to a certain set of docs repeatedly, and frankly, just having links to be able to go boop and jump right over to the Aspire docs was really handy. And you do have to make that noise when you click links. It is a requirement. The other thing that you'll note that you have along here is that not all of my things are actually in a running state. I've got this extra container in here called dbgate. So let's take a look at what that actually ends up doing. So if we come in here and I look at my Aspire host, and I'm going to collapse that here, and we'll go right here. So I have, font size good? Getting nods? Great. I have this builder that, for anybody who's done ASP.NET Core work, this should look somewhat familiar, right? We've got the generic host. We've seen this kind of builder pattern for setting up our applications. Well, shockingly, the Aspire host is itself that same kind of ASP.NET Core builder pattern to go through and do. The only difference is this distributed application. This is what's getting you that nice Aspire dashboard, the DCP behind the scenes. And we can go through and we can add in resources into it. And in this case, we're just going to pull in an arbitrary container. So this is just something hosted out on Docker Hub, unrelated to Aspire. It's just a convenient web-based application for you being able to browse my database. But you'll note I've also gone through and said, OK, I have these environment variables that, for dbgate in particular, that let me go through and specify ports, passwords, and I don't actually want to think about what the password needs to be. Because when Aspire fires up my SQL database, it's going to generate something. I don't know what it is. I don't really care. It's going to put a password there, but anything going through to connect it actually does need to know about it. It needs to be able to have some way of passing those variables back and forth. And you'll note I also put down here with explicit start. So with a lot of resources in Aspire, they're going to be designed to fire up, get running, figure out where they are in the dependency tree. But in this case, we said, you know what? Let's wait. So if we come over here, we can actually just click the button, and it goes, ooh, let me fire that up. And we can see here it goes through firing up a Docker container. I didn't have this image pulled down. It downloads the image, starts the running application. And now I can go through and launch it. And now I can actually just go in and say, let's go ahead and look at my database. And look at that. There's my admin@email.com. It's a great username. And so now we can go through and configure our Aspire host to actually give us additional tools. So inside of your applications, if you've got all of these extra things that you normally tell your developers, hey, when we go to view our database, yes, you can download SSMS, you can bring in whatever you'd like. But in this case, we're going to go through and we've got something built in to see if you go through and need it. One of our projects here, we've added this in, and I think we're down to only one engineer who still likes SSMS better because this is just so convenient, right? The other thing is if you say, well, it would be really nice if we could go through and configure port numbers and otherwise so that people who still want to use SSMS, other tools remember their connections and the previous ones. It's like, well, that's kind of annoying if these things are spinning every time. You can go through and configure the ports so that things remain somewhat consistent. The other thing that we have is this lifetime parameter here. By default, Aspire wants to stand everything up, tear everything down, stand everything up, tear everything down. That's fine for some things, but oftentimes when you have containers running, it's kind of convenient just to leave them running. Once I F5 in the morning, I'm going to be starting and stopping so many times, I don't want you restarting my container all over. I want to be able to leave that thing up and running and keep it going. And so being able to say, okay, leave the container running, I'll take responsibility for terminating it if I need to, right? Giving me that added little bonus. We can do the same thing. I've kind of hidden away some of the SQL related ones as well to say, hey, by the way, go ahead, leave my SQL Server up, right? SQL Server isn't exactly that fast to start as a container. It's not horrible, but again, I don't want to wait for it every time. And I'm going to go through and say, I also want to put a data volume behind it, because if I don't do that, it's no different than running SQL Server in a regular Docker container. It stands up, it's ephemeral. As soon as the container dies, the database is wiped out. Sometimes that's really convenient, especially if we were talking about maybe I'm running UI tests or integration tests. It's like, you know, it's actually kind of nice to have my database containerized because it makes it real easy to torch it and start over. The other thing that we can go through and do is we can actually say, you know what would be really, really handy is if when we added in our database, is if we automatically seeded our database. Because how often do you have this situation where I fire up and the very first thing I have to do to configure my application is, okay, you need to go through and add the following records to your database. You need to get this schema applied, run this script here, reload this backpack here, all of that kind of stuff. Inside of Aspire, you'll note I've gone through, I've added in the database, but I've also added in this on resource ready. Because Aspire has this lifetime for its resources that it's able to go through and leverage, we can say, hey, by the way, when the database becomes ready, it'd be really convenient if you'd go ahead and just apply the schema. In this case, EF core. So we're just leverage the built-in EF tooling from the command line to say, go ahead and apply my schema. And so it says, we are literally just going to go through and apply migrations. And I'm even lazier because I often install the EF tools as a .NET local tool, which means when I first clone, you have to run a .NET tool restore. And that doesn't really work well with my idea of I want to clone an F5. .NET tool restore is an extra step. And so I actually, in the event that the first migration fails, I go, you know what? Most likely case of failure is the tools not being there. Let's just restore the tools and then try again. And then we'll report failure, just because I'm paranoid and I wanted it easier. This may not work for a lot of people because people are like, no, my migrations fail for a lot of reasons. Sure, fine. Again, this is Kevin's opinion of what he finds to be convenient, not necessarily a gold standard all the way through. If people are interested in seeing it here, there is nothing fancy. It is literally process start using .NET EF database update, no build all the way through. The one thing to keep in mind when you are running your Aspire host is it is a running application, right? Picture it like just another ASP.NET Core application inside of your solution. And so if you do things like leave off this no build, and then it goes through and tries to say compile a project that's also in that solution, while the Aspire host is locking that file, well, you get bit. So don't do that. That part is bad. Okay, let's go through and take a brief gander back here. So these are all of our resources. If you want to see something pretty, there's a graph. Right. For more complicated things, I'm sure it's more helpful. For our purposes, this is fairly small. The other thing that we have in here is things like parameters, because oftentimes people have things as part of their applications that are, hey, when you go through and start this up, you really need to insert third-party API secret here, right? Maybe you've put that in a key vault and that's a remote resource. That's my preferred way of doing it. But sometimes people say, you know what, this thing here needs to be a local secret. We can add in parameters that the Aspire dashboard will actually prompt users for when they launch to say, hey, by the way, you need to put this parameter in before the application is actually going to go through and go. The other thing that we end up inside of here is along this left, you'll note we've got a whole lot of debugging related features for us. We've got console output that's actually not that bad. Like, there is a reasonable viewer for doing this. When the Aspire team first released, people were wanting to take this dashboard and publish it out to Azure, and the Aspire team's like, whoa, 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 whoa. We built this as just like a local debugging tool. What are you doing? This thing is not secure. Well, eventually the community went out, and so now they actually have it for like Azure Container Apps. You can click a link out in the Azure portal to say, turn on the Aspire dashboard for this container app environment, and it appropriately puts it behind your Entra ID so it's not just wide open, because as you can imagine, there's a lot of data here that you probably don't want wide open. But we can get very nice logs to be able to say, hey, let's go through and let's pick on the database or similar, right? We can see the commands and everything being able to run. So when I'm running my Aspire apps locally, I now have a very easy way to go through and review my logs. I'm not sifting through Visual Studio outputs and otherwise to be able to go through and do. I have these ones in here. I've got various filterings, clears, etc. But we can actually go a step further, right? Because the service defaults, one of the things that it sets up is structured logging, which is very convenient when you want to, say, start looking at spans or otherwise to figure out, okay, this call was slow, but which piece of it was slow, right? There's parts of it that may end up being database related, parts that may be API related. Hey, I want to actually break down and see where those things go. We'll pick on one here if I can find one. Why does it not show any of them inside of here? Oh, because I haven't actually launched the application to do anything. I launched my cloud-based one. You actually have to launch the application to see something interesting. Who would have thought? Okay, there we've at least got something, right? So we can actually jump in and start taking a look at our spans to figure out, okay, here's how much time was spent doing this. Because this is a Blazor application, we do have a SignalR connection, not just straight HTTP back and forth for all of them. Things get a little weird because of that. But the nice part is, we don't have to think about necessarily setting that up. The defaults got us at least up and running there. If you spin additional, say, container app jobs, you are on the hook for being able to do those spans yourself, etc. We do also get a wealth of built-in metrics. Again, just things that kind of come out of the box to be able to go through and do and it demos really nice because look at that, it's a pretty graph. Right, of being able to go through and look at all of those .NET metrics. Again, things that Microsoft has said, you know what, you probably want these types of things on because assuredly, as soon as you go to production, you're going to be questioning, why is my memory usage so high? Where's my connection counts going, right? Why is this thing timing out? And then is when people most usually go and turn on this kind of stuff rather than doing it ahead of time. So starting and getting people of, hey, this is probably where you want to start, and you'll note this thing's actually like updating in real time. The Aspire dashboard setup for debugging is actually pretty slick. Okay. A couple more things to go through and show. So I commented before about those two link ones. So as far as putting in your own custom resources, a link to an external site is, I think, about the bare minimum easiest that you can possibly get to, where you literally are just calling builder, add external service. But if we look on here, builder has all kinds of things that we can go through and do. Add SQL servers, add templates, and the one thing, if my cursor wasn't moving around on me, boom, there we go. These are all extension methods. When working with Aspire, you'll find that if you go and look out on NuGet, there is a large number of extension libraries for Aspire. So depending on what type of infrastructure you are looking to use, you are probably looking to add a NuGet package for that type of resource. What I mean, I've pulled in ones for MS SQL, I've pulled in ones for container app environments and for Azure. Because that's my infrastructure, that's what I'm going for. If you're doing Cosmos, if you're doing AWS, different NuGet packages, different set of extension methods. So if you aren't seeing what you expect here, and unfortunately on the Aspire docs, a lot of times they assume that you've installed the right NuGet package already. They're like, yeah, it's this method. It's like, I don't see that method. Where is it? Well, yeah, you have to look at what package that's in and then bring that in to be able to go through and do. But adding in additional resources into your dashboard is as simple as builder.add insert thing I want here, and then going through and configuring it. The other thing that we can do is you'll note on the Aspire docs resource, which is kind of just a link, but I've also put in additional commands down here. Because again, when I was cloning this, I was like, you know what, shoot, I have to go through and like install the CLI and otherwise. So if we look, go back to my resources, underneath docs, under these little ... I've got a couple extra commands down here. Now, if you add extra commands, add icons, because it just looks pretty. It comes from a particular Microsoft icon set that you can pick anything you want as long as it's from that icon set. But we can go through and add in additional commands to be able to run. This is oftentimes, I think, where a lot of the power comes. You'll note on my database resource that I have here, I have commands set up for restore tools. Go ahead and create me an EF migration. Go ahead and remove the last EF migration. Now, there's a kind of a catch-22 here. I can run the .NET commands to do those code generations. The part that doesn't work is I still have to recompile my assembly with my EF migrations before those things show up. So it's convenient to run it from here because I can put in a connection string that's pointed to my Aspire containered SQL instance. But it's kind of inconvenient because I also have to remember that, hey, by the way, you really need to go through and recompile before you're actually going to see these changes. I can also say, hey, let's go through and let's push my database migrations one more time because something went wrong, maybe I needed to restart something. If you forget to start Docker, conveniently, because that is probably the most common reason for some of these resources not starting, you'll actually see a banner right at the top where Aspire goes, hey, by the way, I don't see the container host running. Did you forget to start your Docker instance? It's like, oh, yep, go through and run. If, hypothetically, you don't like Docker Desktop, Podman also does work. There's a small asterisk there around networking bits, depending on if you need to reference the container host or not. The well-known Docker internal port, Podman's a little different. You have to set that up manually. But other than that, we do have at least one engineer running Podman here. And as far as I'm aware, working great. Mostly because I don't hear complaining, so I assume that means working great. So for your resources, being able to go through and actually pull in those commands. But we can actually get a little bit fancier than just executing commands. So if I go here, and actually maybe I'll pick on the install one. So if I go install CLI, you'll note I actually get a dialog popped up here with fancy links that I can click and all of this other stuff saying, hey, this is about to run an installer. Are you sure you actually want to do this? It is still in preview, and so I will put that small bit of caution on here. So you'll note I'm intentionally disabling a warning, and that warning is, hey, this is a preview API. We reserve the right to change it on you later. So the Aspire team hasn't quite confirmed that this is the end state, but we can actually pull out the interactive service, and then from there, so interactive service there, and then we can start doing UI-related stuff inside of the Aspire dashboard. So we aren't limited to just the UI that they've given us. There's now extensibility to say, hey, prompting the user to input a value, that's kind of a common thing. Popping a dialog to show information, that's kind of a common thing. So we now have those types of interactions available to us where we can actually go through and build it up. I'll highlight this line right here. The markdown is off by default. So if you want fancy formatting, you have to ask for it. Otherwise, it will treat the strings that you pass in as just raw strings, and it looks horrible. So in my opinion, you always go through and turn that on. But once you display the dialog, you then get to do things like, hey, check if it's canceled, return the data, and then from there, take off running, right? So I've got a little check for Windows because I tried to be friendly whether I was going to do PowerShell or Bash. Have not tested this on non-Windows. So if you do grab my template, warning, I know of at least 3 bugs with it. Pull request accepted if anybody feels adventurous. But the point is Aspire, not necessarily Kevin's poorly written voting app. But we can go through, execute the process, reset the variables, and again, we are just functionally running as a web application here, and we're off to the races. Let's check in real quick because I think we're probably done. Perfect. So after running our AZ up, we now have a deployed application. And if I tempt the demo gods a little bit, The only thing that's mildly annoying, log me in please. So when it deploys out, it also goes through and says, you know what you probably want to debug that app that you just put out, we're going to go ahead and turn on the Aspire dashboard on your container app environment, and I'm going to go through and deploy it out. You'll note here the actual application itself. There's our ugly looking hash to disambiguate, and you'll notice it's activating. This is because by default, Microsoft said, you know what, we're going to try to save you a little bit of money. Container apps have a wonderful feature where they scale to 0. So when we deploy out by default, we're going to allow you to scale down to 0 because there's no real point in just burning credits because, again, this is local orchestration, not necessarily cloud deployment, right? This is for developers working. If the developer doesn't like it, go ahead and dial it down. If you don't like that, and again, because Aspire is designed to be extensible, let's back down here. Copilot, go away. We can actually go through and configure the infrastructure that's going to be deployed. Right? So by default, Aspire really wants to do bicep-y things when we're talking to Azure because it's Microsoft and that's their behavior. But we can go through and each of these resources kind of has 2 different states that we can be in. Right? We use the Aspire host both as a running diagnostic tool to be able to have that pretty dashboard to be able to play with. But it is also used to generate a manifest that describes our application because it knows the relationship between my SQL server, my web backend, and it knows that, okay, my Blazor app, it's got a dependency on the database. I've got some UI tests and external HTTP endpoints. But when I am in publish mode, I'm going to go through and when I am actually publishing out infrastructure, I'm going to go through and change the replicas. Right? So by default, I think it wants to do a 0 to 10 replica set with 3 instances or something of that nature. But we can go through and say, you know what, actually, I want to dial that down and control what you actually generate. You can actually also go through, rather than just AZD up and YOLO it all the way out, you can instead just have it generate the bicep files that you then go and customize, modify, do whatever the needful is. If you're adventuring and you like third-party stuff, there's also providers people have started building to go from this manifest into things like Terraform or insert other infrastructure as code, Pulumi, or otherwise if you want to be able to deploy out that way. Again, separate in the mind the difference between your local orchestration and like a real prod cloud deployment or otherwise because those are 2 kind of separate use cases. You probably still want something different. You'll note I've got this kind of dirty environment variable for running migrations when I deploy out from my local orchestration. You shouldn't be running your database migrations on app startup. That's a bad idea for production, naughty. But again, local orchestration, I'm kind of fine with it. So flip the switch, turn it on internally to be able to make it run. So if anybody is curious about that. The last kind of key thing here is this project dependency. So when you add a project to your Aspire host, we're all familiar with this whole dependency, add project pointed at my other project reference. Inside your Aspire host, it doesn't quite work the same with your regular project references because there's kind of 2 ways that you might want to reference a project. You might want to reference a project like what we've done here for, in my case, my API, to bring it in and say, hey, by the way, Aspire, this is an API project. I want you to bring this in as a resource so that I can go through and leverage it. And you'll note here, this is a project, .NET Conf QA 2025, which matches my project name. And this is a source-generated file. So by default, when you reference a project inside of your Aspire host, there's a source generator that's going to see it and go, oh, project reference. I know what I do. I generate everything I need for that project to use it as an Aspire resource, which most of the time, the projects that you bring in, that's probably what you want. But if we go through and look, we might actually end up wanting to reference more than that. You'll note I've also got a core and a data project here, and only one of those 3 is actually something that I want to be used as a resource. The other 2 are just things that I'm bringing in because inside of my commands I want to interact with my database directly and otherwise. So inside of your Aspire app host CS proj, there is this property hanging out down here called is Aspire project reference. If you are going to bring in a project because, again, you're writing a custom command or otherwise, maybe you've got some shared code that you'd like to leverage inside of there. In my case, I have my DI code for registering my database. I want to use that both inside my main project as well as my Aspire host for when I'm interacting directly. I don't want to rewrite that twice. You do need to set is Aspire project resource false to tell it, hey, this is not something for the source generator. Just bring in it as a regular DLL, nothing fancy. I'm just going to go ahead and use code to be able to bring this in. And there we go. Wrong keystroke. Questions? I realize this is like fire hose version of Aspire of going quick. My hope here is that people take this of what is possible in Aspire and then go through and tweak your own apps to be able to leverage it. Okay. Whatever. It is sets the database when you do the local provisioning to put itself to sleep after 5 or 10 minutes or something. So and then it wouldn't be a .NET Conf if I didn't use the word AI. And I've been good. I don't think I've said it yet. Now let's do the AI stuff. So inside of our Aspire dashboard, you'll note our good friend Froggy or Pilot Head, depends on which version you want to look at. So obviously built into the Aspire dashboard, the Aspire team was like, well, everyone else has Copilot. We need Copilots too. So we have, summarize resources. We have Copilot just straight built into the dashboard. We can use it to ask questions about our resources, investigate logs, try to diagnose problems. And that's pretty cool, right? It's nice to have. It's kind of cool to see. It gives us a way of doing it. But it's important to note what this Copilot chat has access to. Your Aspire dashboard, your Aspire resources. It knows what's here. What's missing from that, especially in local development, is I want to tie that back to my code. It's nice that you can tell me what the error is and where it happened. But if I can't tie that back to what change I need to make inside of my code, that kind of only gets me halfway there, right? You've told me what the problem is. I now have to probably copy and paste your output into Copilot into a different terminal to then go through and say, okay, here's what your other cousin said. Can you tell me what I need to do inside of my code to go through and fix this, right? But we can go a little step further because they went through and they added in the Aspire MCP server. And now this adds a little bit of gasoline to the fire, is because now what we can do is we can say, okay, I'm going to run the Aspire MCP server. For people who weren't at the Copilot talk that we did, an MCP server is just a running application that has tools and actions available to the AI to be able to do things with. And some of those tools and actions we kind of saw in the Copilot prompt, right? It can look at logs, primarily accessing the metrics and logs and structured output. Those are the key tools of this Aspire MCP. Because most of the time, if you're using AI to interact with this, what you are probably doing is saying, hey, I want to figure out what's going on with my Aspire host. So we've got directions down here. We can install, let's try that one all over again. We can install the Aspire MCP server into this. Somebody closed my VS Code instance. I'm not going to mention his name, but it may have been not me. Okay, so if we take a look here, so this we'll do this in VS Code, and then be big and go away. All right, so we're going to run this in large mode. So if I take a look at my tools down here, I have already installed the Aspire MCP server inside of Copilot. And this VS Code instance is pointed at the root of my repo, so it now knows something about my code. So in addition to being able to just look at logs, we can now go through and look at code. Check my, and I'm going to do #Aspire to explicitly reference the tool so that it understands what it's doing. logs for the Blazor backend, and tell me about any auth issues. So when you start running the Aspire MCP server, it's not tied to just that one Aspire dashboard. Because if we look at the RAN list resources, no Aspire app host is running. Well, don't do that. Did I shut it down? No. It's there. Find it. You're going to ruin my demo. Try again before we get too carried away and start insulting you. Yeah, there you go. See, look at that. It's there. All the prep in the world, and AI can stymie you in one shot. So it can now go through, it can take a look at our logs, and it can then start to make connections between what it sees in the logs, especially if there's things like stack traces, and it now has the context of my code to be able to go from errors in my code to fixes in my repo. Right? This is now a major upgrade for being able to debug and solve a lot of these problems. Though I will say, in typical AI fashion, I think most of the bugs I found in my app may have been caused by Copilot, so take it with a grain of salt. But at least being able to go through and debug, because before what would end up happening is I would get an error in my application, and I would say, okay, let me go ahead, copy the error out. Hey, Copilot, I'm getting this error when I try to log in. What is my problem? And Copilot would go, oh, okay, and it would start, it would walk through. Now, giving Copilot access to the Aspire MCP, it can go through, review the logs. If it says, oh, shoot, that looks like a database problem, it can now go pull the logs from the database. Because I'm logging out my SQL queries, because I've dialed the logging up on EF all the way, it can look at what is actually running and say, hey, let me go through and help you with that. If we turn on performance monitoring, you can start saying things like, hey, help me optimize the query. When I go to log in, it's really slow to load the list of questions or list of rooms that I have. And it can start looking through and not just looking at the code that you have, but the actual logs and the SQL that's executed from that code to be able to get it up and running. Okay. Last thing I want to comment on is there is 2 CLIs, and I talked about one and then kind of skewed over the other one. So there's the Azure Developer CLI, AZD, but then there's also an Aspire CLI. So the Aspire CLI is something that the Aspire team put together to give themselves more commands and otherwise. I was running AZD up because that's the command that works today. The Aspire CLI does have a preview command, Aspire deploy, I believe. That is very much an opt-in, set some environment variables, make it run, as a simpler way of going through and doing the deployment. Personally, AZD is fewer characters. I'm less likely to mess that up. But the Aspire ones does give you extra diagnostics. There's also a really key command, Aspire upgrade. The Aspire team seems to be kicking out updates about monthly, which means these things are coming really, really fast. Like, they are running at the speed of AI as far as pushing things out. The Aspire upgrade is more than just rev my NuGet package. Rev my MS Build SDK, rev any other dependencies or tooling changes that I need to be able to upgrade this. So if you're looking to try to keep an Aspire app updated, the Aspire CLI does make that a lot easier to be able to go through and do. It is also the process that is running the MCP server that allows you to connect. So secretly, you probably have it if you go down some of these workflows without even realizing it, because they kind of just shove it and bundle in and go, hey, by the way, we kind of need this to be able to run some extra stuff. So you will find in their docs, the CLI is something that is very heavily pushed, and I expect to see a lot more updates and otherwise pushed down from that way. They do also have Aspire New for new project templates as well, slightly better than .NET New templates. .NET New templates get updated very slowly. The Aspire CLI, they can update on that monthly cadence, and so you'll note that the Aspire New templates that you generate tend to be a little more up to date, tend to have latest features. They don't get as stagnant as some of the .NET New ones that may be taking a while. Last but not least, it also can help generate your pipelines, because why not? At some point, we do actually need to get all the way to prod, and this has been great for local and local orchestration. So there is an Aspire CLI option. I think it's called CI, if I remember correctly, that will help generate out the YAML that you need to deploy an Aspire application. And so you can use that as a starting point for your pipelines for either GitHub or DevOps to say, hey, let's actually get this thing all the way to prod. Again, it's going to be a best guess because everyone does their stuff a little bit differently, right? Everyone's pipeline, a lot of companies, they've got their own set of custom actions or tasks that they want to use to be able to log for compliance or otherwise. So again, the Aspire team's not trying to do all of the work for you, but they're trying to at least give people a good running start so that people don't get stuck and go, I don't know how to do the next step, right? It's like, here's something that works, but we understand that it's probably not the complete solution for a lot of people. Okay, questions? Austin.
I was wondering if the MCP server that gets hosted with the dashboard app, does that also work in the production version?
Yeah, so the question is, does the MCP server also work across the production version? Not currently. However, there's kind of a weird thing there because you can get the Azure MCP to be able to go out and do similar things, to be able to interact and pull logs and otherwise. And when we say production, local orchestration versus actual production may end up being different, right? Because even though the local orchestration is doing a container app, maybe in real production you've got a full Kubernetes cluster, there's something different involved in actually accessing that. And so there may be different MCPs that you go through and pull in that way. Great question. Anything else? Yeah?
Does this only work for a single repo? So sometimes I have applications that they're self-contained, but sometimes they need to talk to each other?
Yeah, so the question of does it only work for a single repo? What about like a multi-repo setup? So you can make it run on a multi-repo setup with two kind of caveats in there. I've got one project where I've got my .NET backend in one repo, and I've got a React app in another repository. I put my Aspire host in my backend repository, and I pulled in, because it's builder.add, I think it's npm package or similar, to do it, and I just literally went .. right? Go up a directory and go looking for it next door, right? So if you oftentimes clone your repositories side by side, you can do things inside of your Aspire app host where you say, hey, if this other directory exists, conditionally add this front-end resource. So you can get away with a little bit of leveraging it that way to do it. So it does work with multi-repo, but you don't get the same kind of parity there. The other limiting factor is if you're doing project references, right? So that CS_proj reference that you add in for the source generator, that is dependent upon MS build project references, which the projects have to be added to the solution. So it doesn't mean they have to be in the same repo, but it's kind of weird to have a solution that runs the project outside of the repo. So again, you can make it work, but you may end up in a situation where you have a separate SLNX file that also references projects from another repository to get that kind of behavior working. But the rest of it should be just fine, at least as far as standing it up. Anything else? Going once, going twice. Ben.
So it sounds really nice for like the startup of like, okay, I can clone and run. Day to day, is it like if I have a small project and it's like you just kind of click and run, what advantages is Aspire actually giving me? I'm like, it's not hard to say with my app. Like, start my database and it takes me half an hour or whatever.
Yeah.
If I need an advantage there, what's the day-to-day kind of advantage of Aspire?
Yeah, so kind of day-to-day advantages, what does Aspire give me, especially if I've got a simple application that's not that complex to be able to go through and stand up? I think it does depend a little bit. So the ones that I've leveraged it very heavily for, the debugging situation, especially being able to tie an MCP into the logs of being able to grab it, that I have found valuable even on small projects to be able to go through and do. Not all apps necessarily need Aspire. If they are a really simple like CLI app, you probably aren't going to gain that much benefit from Aspire if literally your app is a little terminal application, right? It's cool, it's nice, but you are kind of giving some of the stuff up with that. The other big one that I find is just the spin-up time for our engineers is much faster, right? The project that I'm on, it's kind of a revolving door where as engineers maybe between clients, they tend to show up and we go, we've got you for 2 weeks, great. And most of the time for a lot of projects, like 2 weeks, that's your entire onboarding, right? Like you are not productive in that 2 weeks. It's kind of a meaningless time. But we've been able to have people come on, be up and running in a couple hours. It doesn't take a lot of effort when we don't have a lot of work for people to be able to say, hey, you know, clone the repo, F5, you're off to the races, right? That, for the most of it, for our project, that gets people up and running fairly quickly. We do have a key vault that we put all of our secrets in rather than having them local. So it does mean that to onboard a developer, we have to add them to the right AD group so that they can actually hit the key vault. Otherwise, the thing doesn't start and that kind of thing. So there's a couple steps there, but it's very close to add developer to groups, clone, F5, run, and we're off to the races, which is absolutely amazing. So yeah, so I would say that the debugging are probably the biggest ones. And then just the consistency. Like we don't often fight too many issues with people's environments. This does make the sweeping assumption that you do have a Docker host running on your machine, right? That is an outside dependency, but at least for a lot of our people, they usually have that already. And for the few that don't, it's like, yeah, just go install Docker Hub, right? And get up and running, and you're off to the races. Okay. Last one. Yeah? Good question. So the question is, how resource intensive is it? The Aspire dashboard, hardly anything. It's a fairly optimized ASP.NET Core application. What does get fairly resource intensive is when you start adding in resources. Because the resources that you pull in can be quite intensive. Like an Azure AI Foundry local instance, it'll be as intensive as the models you're going to run on it. Because you can run Foundry local out of here, and that's great. But if you start pulling in a large language model on a small machine, you're going to be hurting. For us, for our projects, we've got a SQL database. We use Azure Write for a storage account emulator. And then ASP.NET Core and a Vite front end. So our development machines handle it just fine. For other people, I've seen especially, you can run Cosmos in an emulator. Again, depends on how big it's going to be because Cosmos can easily be a resource pig to go through and do. So the Aspire itself is not resource intensive, but there may be a question to be had about the parts of your application that might be resource intensive, right? You are not limited, though, to just local resources in the dashboard. You can point them at cloud resources instead. So if you say, hey, by the way, you know, running Cosmos locally in an emulator, that's way too much. Our devs can't handle it. Our devs are already using, you know, a shared Cosmos instance out in the cloud. Great. Plug that in as an Azure resource, and what that gives you is, one, a dependency that you can reference for your local API project or otherwise. And then two, it also populates your connection strings. That way it brings all of that in, and you don't have to worry about figuring out what's the host, what's the port, how do I do the connection string. Most of the time on those remote resources, it's going to be relying on like an AZ login, so the Azure CLI, to be able to do the appropriate authentication back and forth. So again, outside thing that we expect people to install a lot of times is the Azure CLI and be logged in appropriately. So if I switch my Microsoft account that I'm logged in at, I can now hit this other project but not this one. So often when I switch projects, I am going through and re-authenticating with whatever account is relevant to that project to be able to get it up and running. Great, because right now I'm running on my personal one, but I can't be AZ logged in on my personal and then hit my work project and still expect to have access to that remote key vault in my case. But we also have, on that project, we have a Foundry instance. We don't run Foundry local because the models we're running just would not, like, our laptops are decent, but they ain't that decent. So we actually leave those resources out in the cloud and just say, hey, we've got a shared dev resource out there. Everybody connect up, but it's still a dependency that we can reference and have all of that service discovery and connections pulled through. Pause. 2, 1. Thank you very much, everyone. We're going to have just a couple minutes where Dan comes up.
Sounds like I'm good.
It's good. Well, hey, this is Dan. He is another one of our amazing developers here, working on a variety of different projects. Recently got off some stuff with a utility, a big utility back east on an island with about 8 million people, trying to keep the lights on back there, if you can guess which one that happens to be. So anyway, without further ado, Dan, take it away, man.
Thank you. So you've probably already seen the title, and before people get angry about what is happening here, we'll get to it at the end. We'll talk about what .NET does well, but today we're going to be talking about machine learning. Is it blasphemous to do this? You know, if you're a Python developer, it probably is, but if not, it probably still is bad because it's .NET, and it's going to be bad. But that's what we're going to be talking about today. I have a QR code for the Git repo to talk about what's going on, and then just a little bit more about myself. I think we already talked about, but I am a software engineer here at IntelliTech, so that's where you're here currently, and I also run the Spokane .NET user group. So please come if you want to hear more about .NET. We do monthly meetups. We actually have one next week, so to talk about all of the things that happened last year. We're going to be partnering with the Python user group, so we're going to be talking about all things 2025, the outages, and AI mainly. But moving forward, so the background and domain of this project, in my free time, I like playing tennis, so we're going to talk about some of the things that, you know, if you're not a tennis player, some of the things you need to know about tennis and why I went with this. But then we're going to go over architecting the model, usage in .NET, and then we're going to compare it against Python, and then finally some takeaways and next steps about machine learning in .NET. So first, with the background and domain, I have a pretty boring life. How I spend my time is coding, tennis, making up these little graphs, and then cats. So, you know, this has no bearing on actually, but I thought it would be helpful for a little bit of why I chose tennis. So when I originally did it, I wanted to just start coding an app. You know, this was from Kevin. I wanted to use Aspire. So this app is an Aspire app, but I want to just use it. I've never used it before. I was onboarding into a new project that used it, and I wanted to kind of learn a little more of the intricacies of just, besides just the, okay, go here and then run it. So that's one thing. But then the actual app that I came up with was, okay, what hobbies do I have? Well, I like doing mountaineering projects, but I don't want to write an application about mountaineering because then if I get something wrong, that's life-threatening. Okay, so tennis is another hobby I have. Okay, tennis is kind of a hoity-toity sport. People, when they go to coaches, that's like, you know, there's a lot of stereotypes about going to a tennis coach, but it's very expensive as well. And when you go, it's like an hour-and-a-half session, maybe 90 minutes, where they like learn about you as a player and then give you tips. So they don't know anything about you before, they don't know anything about you after. So personalized coaching tips is part of the vision of what I was trying to go for. And breakpoint, for the context, when you are serving, you should win your game. So if you are about to lose the game you're serving, you're on breakpoint. So that's where breakpoint is, and then AI is obviously because I'm using AI. And then second is tracking over time. So like I said, a single expensive coaching session is only a snapshot. So a system that can learn patterns as a player, or learn about things that you didn't like that it recommended. And then finally, free, right? So tennis and other sports already use these kind of kinesthetic models to improve players, right, at the professional end. How hard could it really be? And of course, I have the tendency to say, oh, how hard could it be? I'll just do it really quick. Not easy at all. So getting into a little more of the actual technical things, and please stop me if I'm going too fast or if you have questions, and we'll do a Q&A at the end as well to kind of review some of the things. But if you have questions, please raise your hand. So architecting the model. So with all the capabilities AI has, and Grant talked about it earlier, things are becoming cheaper to do that used to be really cost inefficient and really hard to do. So with the capabilities it has now, especially for personal projects, start at the end. And what I mean by that is instead of like picking a certain path, then finding out the pitfalls it has later, start with the end things that you want it to. What are the ideals or what are the needs of the project? So, and once you start having those needs, it kind of kicks down the can and say, okay, now I need to answer this architectural question. Now I need to answer this architectural question. So some examples, I wanted to take just videos of tennis. So you play and then you upload the video. So that asks the question, how do I get either numeric data or how do I analyze that data from videos And there's a couple different ways we'll talk about. The second is provide accurate coaching feedback. I like playing tennis. I wouldn't say I'm a particularly amazing tennis coach. That's why I do software engineering. So how do you actually get like real coaching insights from just a video and plain data? And then finally, don't rely on overly labeled data and an expert up front. So I'm lazy. I don't want to sit there labeling hours and hours of tennis videos saying, well, his footwork was bad, his elbow was too low, his swing was too short, whatever, right? I didn't want to do all that. So where do the coaching insights come from then? So to start, the input. That's kind of the first question that I had. How do I process a video? So there's kind of some typical standard ways that you would approach a video, right? Multimodal models are now kind of the cool thing to do. You just give it a video and say, analyze my video. So the pro is that it's really easy to set up. You just have a model, call it, send the input. The con is, how do you make it structured? How do you make it more specific to your domain, right? You can ask really nicely in the prompt, please make it a good response. But besides that, it's a lot harder to control, especially with the new models. And so an image classifier, you get a lot more control because you're actually taking, okay, I have a structured output that I'm going to get, and I've defined the set of labels. But, like I said before, I'm lazy, so that requires a lot of data. So that was the original approach I had, and then I started looking up how much data I would need for like a simple Azure vision to be at all good. It was a lot more than I thought it was gonna be. So then finally, pose estimation. Kind of the original spark of the idea was those videos online where you see the person's joints and then an AI summary comes up and it's like, your elbow is too low. So I looked up, there's some free models online that Google produces called MoveNet. It's a pose estimation model, and it points out 17 key joints. So technically you get your eyes and ears as joints. Sure, don't use them, but sure. But knees, your hips, your elbows, your shoulders, all those things. So that detects 17 key points in a body, and it's really fast. So, okay, how does joint position correlate to a good swing? Now we're just iterating and going forward and forward and forward to try and answer the question, okay, now that I've kind of chosen this path, what are the results? So how does joint position correlate to a good swing? So some of the problems are in tennis, there's multiple swing phases. You're not doing the same thing over time. When you do a tennis swing, you swing back, you swing forward, and then you follow through. And then swings are not the same, right? A numeric analysis of joint data wouldn't make sense because not only is each person going to be different, but also the video angle might be slightly off. So we can't make overarching rules based on the numeric joint position data. And then finally, there's a lot of data for rules-based. So if it's by frame and there's 17 key joints, and we have other features as well that you can calculate, and we're not going to use the nose or whatever, but there's over 400 frames in a 15-second video, assuming 30 FPS. So there's too much data for us to do anything meaningful with it. So moving into my initial design, we have an Aspire app that at the top, you have an Angular app front end that uploads a video, does all the basic things, so that this top half is pretty basic. But then you get into how do you actually generate the analysis. So the way I ended up initially doing it was I have a custom AI model that I used that was a classifier. So it was a regression, fast tree model. If that matters, it doesn't really matter. We're going to change it a couple times. But initially, it was leaves and nodes. So you generate. I trained the custom data on some labeled videos of this is how good the swing is, right? So I had pro videos, I had beginner videos, and they were just really simply, okay, this video had swings that were of quality 0 to 100. And initially, it was actually USTA rating. So USTA is 1 to 7, so pro is 7, but it doesn't matter. It's 1.0, So that'll change, but so MoveNet, I take each frame and get rules-based creation of the swings for each joint, send it into a swing analyzer, output a USTA rating, plus the highest negative weighted feature as the form indicator, and I'm going to talk about that in a second, what that means. And then I just send it to OpenAI and say, please take this whole kind of more technical analysis and give me some drills as a list of strings. So let's talk about what this highest weighted negative feature means. So in AI, now that I've trained, and we'll get into the code a little bit in a second, but when you have AI, right, you have a list of features. So each feature becomes in the fast tree model or different, it becomes a weight at the end of the line, right? So maybe it's your elbow, wrist, and shoulder angle becomes a feature that then can contribute 0 to 1 to the output. So in the case of for this model, the shoulder angle was really highly rated because what it meant is this score, this difference of numeric value, highly correlated to the result. Pros all kind of had the exact same shoulder angle, and beginners kind of had a really bad shoulder angle, right? Because when you see a pro hit a tennis ball, they're really loose, they're coming through the whole ball. But a beginner, they kind of do this thing where they're just it's like a ping pong, right? So it's very different. So this was my initial design. And the reason I bring this up and the reason I'm getting into the technical details is because I was not sure initially what I wanted to do, but a lot of this planning was done with Copilot. So that's kind of a final takeaway, but we'll get into that. So this was something I was like, okay, we're using kinesthetic data. We have a bunch of arrays, basically, of floats where it's showing the position. How does that mean anything? Okay? But the middle part of this rules-based creation of the swings, so for each phase, I basically had a bunch of rules trying to dictate how do you determine a swing. And I was having really hard time writing that code. So I said, well, maybe AI will do it better than me for writing the code. So I said, okay, just put another model in the middle there. And I take, instead of you doing rules-based, I basically just take all of the arrays, and for each frame, classify it as a different swing, or as a different swing phase. So back swing, contact, and follow through. So then now I'm taking the hard parts of the code that I was writing myself and just throwing a model at it in C#. So then I changed some other things, not as important. We can get into the details a little bit later. But let me show you a little bit about what this looks like, because I can talk about it as much as I want, but even my eyes are kind of glazing over, so I just want to get into a little bit of what that actually looks like. So like Kevin was saying, oh, that's not where it is. As Kevin was saying, nice, pretty graph. Demo's really great. This is my Aspire host running, but the only one that matters right now is the front end. So I did the back-end coding, and I was like, oh, I want to throw a pretty little UI on front of it. AI, go do that. You do that while I'm coding over here. So it does work. We'll see. So I log in. I have a user that I need to create. I just blew away my database. And a couple things. I give it a USTA rating and a dominant hand just so the AI doesn't have to figure those out midway, and the drills are recommended based on how good you are as a player, so that's the reason there. Okay, so let me pull up my video that I took this morning. I went and to my tennis club, went to the ball machine, and hit some tennis balls this morning. So right now I'm just doing backhands. So this is the video. I haven't uploaded this, so we'll see what the outputs are and see if it's at all good. But it's basically just 30 seconds of me hitting a bunch of backhands, and that's it. So we'll upload that as the type backhand. And that should be the one. OK. And while this is going, I'll talk a little bit about the process for training. So in .NET, the hardest possible thing that I did for this whole project wasn't training the model, wasn't architecting the model. It was actually just loading the first model because MoveNet was a already downloaded PB file on TensorFlow. So TensorFlow is like this huge Python community of models that are really great, but it was really tough to load. There was like code online in different forums that said this is how you upload and use a saved model. Nothing was working. So I was getting a little frustrated because .NET was claiming it could do things, but just not at all working. It was running into like tensor errors or output errors or conversion errors. And I was like, I'm not seeing any documentation. That's the one problem with machine learning in .NET is that the documentation and the support in the community is just way lower. Okay, so we iterated a little bit, me and Copilot, and I was like, okay, well, if the standard way in Python isn't working, let's go to like a universal. There's a AI format called ONNX, that basically it's a frozen image of the AI. So you upload that. So I converted the model, so the MoveNet model, and then tried to upload that. And I was using all the different, so ML.NET is a library. There's TorchSharp. It's kind of the equivalent to PyTorch. And I used, then there was finally an MLNet Onyx. That was the one that finally ran. But the hardest part was actually just running the model, which is kind of funny. And it should be SignalR based and show when it's done. OK, well, whatever. OK, whatever, didn't work. But so now we have a couple things that appeared on this page. So the first one is a training progress summary. So the thing I said earlier, I want to have a AI learn about me. But if I have 50 plus analysis, I don't want to load that into the whole context window and have that learn. So the way I ended up going about that was there's a progress summary. So after each analysis, it goes and generates a summary about what happened last. So this is a little spoiler about my score. And the current, where's my mouse? The current model is 0 to 100. So 100 would be a pro swing. And it looks like it gave me a 66. So it looked like the key frame that it didn't like was, and here you can see what MoveNet is taking in. So the joints that matter looks like my knees, my hips, my shoulders. I got my nose in there. And then the wrist. So it looks like this is the thing that it didn't like. It didn't like my backswing the most. So we'll go down. Yeah, so it looks like the backswing, the contact, and follow through were all kind of average, which is pretty accurate for me as a tennis player. I'm like an average tennis player. I like playing, but don't have anything specific. So recommend some drills out here. Perform shadow swings, focusing on a low to high swing path. Start with the racket dropping low. So very specific drills that then, if I mark as complete and I find not helpful, and we'll see if the AI is being helpful today. So what I did there, to clarify, is I said it wasn't helpful because my problem area actually isn't the one you identified, but instead my preparation. I was too late to hit the ball in this case. I didn't actually know. I just was figuring out. So on the next analysis, it should take that into account. So we'll upload another video, and I'm suddenly going to get really good at tennis because we're going to upload a video of a pro. And let's, I gotta pull the video. So the video I'm now gonna pull is a video from a guy named Yannick Sinner, who is the #1 tennis player in the world right now. And he is better than me at tennis, surprisingly. So for some reason, I don't know. He's my age, which is also very upsetting. So here, we'll watch his video, actually, because I think the comparison is going to be good. So this is him warming up. So you see it's spliced together, so it's just backhands because you need to be by stroke. But yeah, a little different. He's a pro tennis player. And he's also European, so he's just going to be better than me at tennis. That's just how it goes. So we'll upload that, and while we're talking about it, we'll figure out what's going next. So what we just saw there was a combination of 4 different models. And in reality, it's actually 6 models because I've added models, so it's per phase, so you score them. But that's really hard code to write that then suddenly becomes an AI task, right? Then you have other hard parts of the code where it's, oh, how do you figure out what's important in features, or how do you figure out how to train the model? You have to have good data then, but the problem scope changes, right? And we're going to shift back to my PowerPoint to go to the next step while it's loading. So some takeaways and next steps. So some of the things that I learned while doing this was this stuff, but I'll talk about that in a second. But the biggest one is actually the iteration with Copilot. Because initially I came to it with I wanted to do an image classifier because that's what I know, and that's what's in Azure, and I'm going to spend Azure bucks because those are free for me, and I don't want to do other things. And this was the approach I had, but in reality, that it didn't actually fit my thing. It was just what I knew. So the second bullet point, use the right tool. I wasn't using the right tool because I was doing what I knew, right? And I think a lot of .NET Conf and these things are trying to expand what you know, what you're comfortable with, and use the right tool instead of the one you know. I'm just going to get some water real quick. But now we'll go through each of these. So the first one is leverage AI. So just start iterating, approach problems with a new tool. And I don't just mean Copilot, but I also mean as a feature, right? Don't be afraid to replace bits of code or services. And you have to do it judiciously. You can't replace a database update with, hey, AI, you go do the database updates on the simple code, right? That doesn't make as much sense. But these complex bug paths, or these hot paths in your services where you're trying to do a lot of fuzzy things, AI is going to do better, if not amazing, at what you're trying to do. And don't be afraid to stretch your simple little CRUD app just beyond a little chat window. I know that's the cool hip thing that Microsoft wants to do, but it's not. Guys, it's not that cool, I swear. The second, like we talked about, using the right tool. So we'll get to it in a second. I'm going to use the P word. But I wanted to do this in .NET because that was the talk. It's .NET Conf. It's not whatever. But as much as I love .NET, use the right tools throughout the whole process. So we'll talk about later the next steps. I rewrote. The model that I initially actually wanted to do and Copilot recommended was a 1D CNN. So it's kind of has more temporal knowledge because one of the problems with my current approach is I kind of have to give it all the meta data about what happened before and what happens after in this swing. So right now it's kind of more frame by frame. So you get some over-reliance on single frames. So like the one I pointed out, I don't see anything particularly wrong with that frame compared to the rest. I would actually have said, in my swing, it's the follow-through generally that's bad. But use the right tool. So in the later app, I'm going to be changing this to be a Python trained model, but then I'm still loading in .NET. Because the reason it's nice to load in .NET is because then I don't have to use new code to do the rest of it, right? When I run my Azure function, what's actually going on is I'm taking an analysis request that's from the database, that's a shared model in my EF Core project, and then updating this analysis request with an analysis result. So all of that code is pretty simple EF, right? It's just take item from database, load up this service call to get the result, and it's basically just getting a score, and then I'm calling out to semantic kernel to then get my coaching feedback, and then I have this whole entity table of the recommended drills, which you can then leave mark with feedback, or then you have to load up the history. All that stuff I want to do in .NET. Like, I'm a .NET developer. EF Core makes sense to me, but the tool wants to use Python in the middle. But I can still load a model and have just as much success, but train the model in Python and then deploy the model in .NET. So moving on to the third point, steal others' work. Like all great artists, developers are great at stealing others' work. Copilot is basically just a really good thief because it's just taking other developers, right? I don't know if people have seen the recent Stack Overflow questions rate. It's basically plummeted since AI came out in 2022-ish, when questions basically dropped because people stopped asking Stack Overflow. Now they're just asking Copilot to really just look at Stack Overflow. So we're still stealing others' work, we're just doing it with extra steps. And don't let AI people tell you they're not stealing. But, so steal others' work, right? In this app, I'm using MoveNet. MoveNet is a pre-trained model that's going to do better than I've ever done on a custom model because they have lots of data, they've had lots of time, and they're better engineers probably. So utilize pre-trained models for answered problems or as part of your solutions, and that extends to things like Azure. Like, don't rewrite document intelligence. Document intelligence has been done well, and there's other ways to do it, but like if you specifically want document intelligence, don't reinvent the wheel. So that's the other thing that's kind of important on this thing. And then finally, build cool stuff, right? Find your passions, find a gap, and just build something, right? This is the time, and whether it's vibe coding or not, the speed up of development has been really cool. Like personally, I had never done big projects before. Like I had college projects that were on my portfolio. I did other things, in prep for job searches when I first joined IntelliTech, but like I had never really done something that I wanted to do. I found that to be a scary thing to do, of like, oh, I have to like know so much knowledge and have to have so many things configured to just start the project, right? To set up, and we're also in a time where it's a lot easier. Aspire makes distributed applications easier, but still, you kind of have to like, I have to be able to set up a database. I have to be able to know and choose all these different things. I don't even know the choices, right? But just start doing stuff, and it's going to be super fun. That's all I want to say here. We're going to go back and see if I get my analysis result. And I swear, I promise you, this was working before, where you didn't have to refresh the page. Whatever. Oh, the AI did not like the pro swing. So that is interesting, because when I upload it on a different account, he always gets high marks. The AI likes Sinner. He's part of the training data, so he should be liked. Apparently, I am much better than him. Let's see, 64 versus 66. Okay, not bad. But if we see the updated training progress, Daniel Rivera continues to focus on refining his backend, and that's just because I only uploaded backends. I also had forehand videos with ongoing challenges in backswing position and contact timing. Wow, so it really doesn't like me. New drills targeting horizontal racket placement and wrist snap timing built on previous emphasis of low to high swing path. So progress is steady. That's funny. So this is the result. So if you saw at one point, it called out what frame it didn't like. It called out this frame in the GIF. It's a little too fast. It generated too high of an FPS apparently. But it really doesn't like this. What is it saying here? It's too small. It doesn't like the follow through. So let's look at what the follow through recommendation was. It really likes this low to high thing. Shadow swings with the ball toss instead of pure shadow swings. So this is kind of in response to me saying I didn't like the shadow swings. So instead of pure shadow swings, toss the ball slightly higher. So that is kind of the result of, and that's, yeah, so this is the one problem with AI in demos. It's variable every time. But let's get back here. Okay. So any questions before I kind of go on to next steps and then wrap up and go into a QA? Is there any thoughts? Go ahead, Chris.
On step 2 there, use the right tool. So why is Python self-evidently better than .NET for what you're doing?
Yeah, so, where did this, did I skip this slide? I skipped this slide. Dang it. Okay. So Python, the biggest reasons Python is better than .NET is the mature framework. So the number of models and actual architectures of AI that Python has access to is just more than C#. So like specifically, C# has a lot of the basic models, right? Just tree models or simple regressions or like gradient models. But anything that's like temporal based, it's just not going to have support for built into the framework. So if you, because of the way the code, and yeah, it looks like I skipped slides, so we'll get into the actual code in a second. But the frameworks are just better. So like PyTorch, scikit-learn, TensorFlow, those are just better than the C# equivalents. but second is the large community, right? It's just momentum that C# isn't the AI language. Python is, right? People, when they want to do AI, gravitate towards Python. So because of that, they have a larger community, people developing really amazing models, helping others, and just have more code to train on. So there's a lot more rapid advancements in this way. And I think more simply, for like POCs, which is a lot where AI kind of lives, Python is just faster to set up. Did that answer your question? And then for C#, why I would use C#, I mean, it's C#, right? So in my mind, it is like pretty close between these two, but in reality, there are some advantages that are, besides developer familiarity. I think the biggest one that I found was consistency in code, right? So like I said earlier, you're talking to a database, you're interacting with blob storage because that's how I've architected this thing. Now I can do those in Python, but I know how to do this in C#, and I might have code already in a service to do that, right? So on the front end, right, the GIF of the person doing the swing and having the MoveNet, that was all from blob storage, right? So I have code to already interact with blob storage written before, so why not just leverage that code again? I don't need to have duplicated entities. I don't need to have duplicated services in Python if I'm using C# throughout the stack. And I'm going to go back because I definitely just skipped slides. Yeah, so after the demo. OK, so the usage. So there's a couple things that I'm going to point out, and I'm going to zoom in on them just so it's a little easier. That's not what I wanted to do. OK, so ONNX is the universal kind of, it's a universal output for models to be loaded because it's basically freezing what the AI graph looks like, so you can call it. But it's very simple, right? So session option. Session is just kind of the AI inference session that they call it. I happen to put this just so it's, because I'm using floats, it required this little flag. But then I just load the model. And the model is just a saved .onnx file in my repo. So I actually have it committed because those files, because they're frozen graphs, are pretty small, right? There's other kind of formats that like Python uses, like .pb files, where you have the variables in a different folder. Models aren't that big. Just a pure regression model is pretty small in terms of like actual file. Like you can use getlfs to throw them in there. But this is how you call a model. So this 3 lines of code took me over a week because I could not figure this out. And I used like 3 different libraries. But yeah, that was actually the hardest thing to do. The second one, the pipeline. So in the idea of machine learning training, you have an idea of a pipeline. So the pipeline is what you actually are training the model in. So in this case, I have some transforms. So I take the data, I transform it using features. Features is the label I have for it using z-score. And that's just so, just basically normalizes the data so it's more understandable to the AI. I have a multi-class classification there. And then the multi-class classification is when I'm actually training. So it's of the light GBM. And I tried different models. And that's the one I found the most. But it's just a tree model. So it trains for 300 iterations or until it's getting worse, basically. And then I get out a predicted label. And then finally, before people just be like, oh, this code makes no sense, it does not make sense. So let's be clear about that. But it is, the documentation, especially in Python, is pretty good for these different types of classifications. So I actually reference a lot of the Python docs for, because this is using MLNet. MLNet is based on PyTorch plus scikit-learn. They're kind of a combination. Because there is also Torch Sharp, but that has weird intricacies with it, and I couldn't get working. So yeah, it doesn't make sense, but look at Python and look at better engineers than myself to explain those. But at a basic minimum, it's just training with this number of iterations, right? How many times does it get to try and be better? And how fast does it learn? How fast am I gonna change those weights of the output So the reason it's changing at 0.05 is because if you change in big jumps and then you're wildly different, how do you know that you just didn't step over what's called a valley or a hill, right? Because when you're trying to approach like a trained model, you're trying to approach a local maximum or a local minimum, depending on what you're going for. Like I'm going for a local maximum. I want it the most accurate, and a local minimum would be a different kind of regression model, but I don't want to step over the big hill that then actually be my solution. So you have pretty small learning rates when you have these number of features. But like I said, this is all gibberish in a general sense, but it works out. And then finally, just the using. So because MLNet has a bunch of conversions that you need to do, you basically have a list of inputs and a list of outputs, just like any function, but they're just named Onyx values because of the way that the variables are saved. So I have the code all there, but that's not really the important part. It does work. That is what I'll say. But yeah, going back to the Python, this is where you can see these lines of code. This one, Python, that's a one-liner. This one, it's like a three-liner. So yes, C# is always going to just be more verbose than Python, but especially in the realms of AI where tensors are a built-in thing to, they're not a built-in thing, but they're kind of a core thing in Python. So you kind of have to go out of your way to use it in .NET. But that is, I'm just going to skip all through this. That's going to be it. I hope at a minimum you learned something a little bit about using different tools in .NET and trying to push yourself beyond what is comfortable, but at the same time, using the right tools for the job. So thank you.
Do you want to do questions?
Oh, is there any questions?
Any questions?
Yeah, go ahead.
So when you're validating the output of these models, how do you control for versioning on all of the different models that you want?
Yeah, so.
I assume that
Correct. Yeah, so the question was, how do you handle versioning in your models? Because when you change outputs, obviously it's going to change most of the surrounding code. Is that correct? So there's a couple things. So first, in a beta stage, don't be tied to the code, right? So initially, your outputs should be, or if you're changing one thing, don't change the other. So you have inputs and outputs. If you're going to change your inputs a bunch, keep your training and your pipeline the same. So then you're not getting random results, right? If you change two variables, how do you know what's going on? So that's the first thing, is change one at a time. The second is once you have a model deployed, there is ways to version in ML, in ML.NET, the library specifically, just like there is in Python, right? That capability is less built out, but just like anything where you're calling different services and like an API kind of level, where you have a version 1 and a version 2, you're just basically going down different paths. Does that answer your question?
Yeah, and then I guess the other thing is, as you were building this, what was the variability in just like the results? Like, if you were to like set up, let's say, unit testing or something for like no good, no bad swings, like, were you able to more or less see consistent results from the API?
I was. So the biggest thing, and I'll repeat the question, so how do you account for consistency and how do you test for that? So in any sort of machine learning, there is a lot of metrics that you do when you train the model, right? So part of training is validating the testing. So you basically do a training split. So on the training set of data, it doesn't actually use all of the training data to result in the output. Instead, it takes a split, maybe it's 80-20, takes 80% of the data that you've labeled and results, so it trains on the 80% and then tests on the 20%. So it can validate the output. So then say it is really bad at detecting a good swing, it's going to result in a high, maybe R squared, depending on the metrics you use. But in machine learning, it's at the training time when you can validate the variance. That basically each model says, I have X number of variants depending on the metric. So R squared is one, mean squared, the Z-score, all these different kind of metrics that when you train the model you get. And one of the notes is basically one of the next steps I need for my model is I need more data because I have around like 400 swings pulled out and labeled and stuff, but that's pretty low because it's a 0 to 100 quality score. So it's, it's not exactly mean because I have other things where I'm using an ideal player profile to extract the top derivations of your swing to like, here's what a good player looks like. So I have a lot of videos of good swings and use that to determine as a player, how do you improve, right? Reference these kind of swings and these kind of data. So my distribution is not, it's basically not 4 swings per 0 to 100, right? It's more kind of highly weighted to the end and the beginning. It's really easy to get beginner swings online, really, really easy to get pro swings, right? Because they have matches that are on YouTube. It's harder to get intermediate because they're generally playing random tournaments, if that makes sense. So at the end of the day, more data is going to generally help with variance. But during the training pipeline is when you actually find out. You can, when I ran in this project, there's a console app that I did all the model training from. And also a Python script because I also tried the Python. But for C# stuff, you can output these metrics from ML.NET. And all the frameworks are going to have metrics you can output as from the training pipeline. Any other questions? That was a great question.
The venerable Mr. Sullivan has a question here at the front.
I was going to let you keep time if you're looking to move to the next session.
No, go ahead and ask a question.
So this was a little bit. Oh. All right. So I saw ground strokes for backhand, forehand, low to high, top spin.
Yeah.
So when you start taking a look at other strokes, whether it's serve or maybe a backswing in which you're trying to get the backspin approach.
Like a slice, sure.
Sure, exactly. So do you think that you have a lot of work to do in changing the configuration for like test for fitness that's going on in that conversation? I mean, do you have a lot of work to do, or do you think that the way you've set it up such that it can still know the right answer without you having to, I guess, spin a bunch of dials?
So for the first one, it depends on what stroke you're talking about. A serve is going to be a completely different type of hit than any other ground stroke, right? The motion is not at all similar in terms of the joint data. Because it's based on, initially, the input data isn't actually the video. It's going to be that array of joint positions, right? So the joints of this swing versus this swing is going to be completely different. So the serve is explicitly an enum that's different. But in the training data, I actually use slices. So in my training data, Federer is one that I have for backswings. That player is just historically known. He doesn't hit a normal backswing, right? So I've tried to build into the model that it's not necessarily what the backswing looks like, right? There has to be other features that you pull from it. So if that answers your question, so like an approach shot versus a backswing, like a backhand topspin versus a slice shot, depends on the data.
So I guess to answer the question for what I heard you say is that you can enumerate some of the things that are like wildly different, like the serve to the ground stroke, but you think that you've brought enough data in such that you can deal with the variability of somebody's stroke. So I don't know if you can do one-handed, two-hand backhands, but you can take it. I mean, maybe it's a Pete Sampras that I think traditionally had a one-handed.
Yep. Federer has a one-handed.
Yep. And so you're not saying, well, you don't look like Agassi, so you're not very good.
Correct.
Right. Okay.
And so to clarify, this is a little more like tennis domain knowledge. So a lot of it is like based on what I know in tennis, right? So I was trying to not encode a lot of the knowledge of like what kind of player you look like because different players. So have I done that successfully? Probably not, because the data set isn't 10,000 swings, right? But the model and what I had tried to do is make it generic enough so that it could be with the right data, right? So part of the next steps is just straight more data, right? Get more of the variance, become more generic, but not change any of the actual code, but just retrain the model to better understand those different weights, if that makes sense. Because one of the biggest things I actually had a struggle with, and one of the reasons I went to a swing phase classifier to begin with from the initial code is what I was doing to test my code initially was I was just running pro swings. And I actually got to a point where my code, my rules-based heuristics for what a swing looks like throughout the different phases was really good for pro swings. It turns out pros are actually good at hitting the ball. But then I trained the data, and I was like, oh, it's great, I'm going to train my model. And then I put all of the training data in, so beginners, intermediate players, advanced players. Turns out beginners don't look like they're actually swinging a tennis racket. It sometimes looks like they're just sitting there, right? Because some of the videos, it's like this. They're just doing this thing, right? Or maybe it's a forehand where they just go like this, a ping pong swing. Looks very different than a pro, right? A pro's really easy. If every swing you're gonna see from like a video of Sinner, he's gonna have the same kind of load up, the same kind of follow through, because he's a professional and doing it every day, right? So that was actually one of the harder things, was the variance of a beginner, and how do you not overfit to what a swing should look like, but at the same time, fit to what a swing should look like, so then the beginner knows that they're doing it wrong. So that was one of the questions that was hard to do. How do you detect them but not get messed up with them? So thank you, great question.
Awesome, thanks, Dan. Give him a hand.
I wish.
29-year veteran of Microsoft. He is one of the architects on their M365 team. I think specifically around some of the APIs and things like that, right?
Mm-hmm. Copilot Extensibility.
Yep. Great, Copilot Extensibility, all that kind of stuff. You will notice that he was not originally from here, and he's from Coeur d'Alene. No, actually, you're from. He came from the other side of the pond, and has joined us over here. Seattle, yeah, right, that pond. But I think another pond before then. Cool. So I'm going east. So anyway, give a hand to Gareth. Thanks for coming and joining us.
Thanks so much. All right. So thanks for still being here at the end. I want to spend about 45 minutes talking to you a bit about Copilot 365 extensibility. So thank you for the introduction. I've been at Microsoft, as you said, about 29 years, which is pretty freaking scary. And you can imagine I've done quite a lot of things in that time. It has never been as bonkers as it is now. I hope bonkers translates appropriately, transatlantically. The world is a really crazy place now, and our corner of the industry is an exceptionally crazy place. Everybody is running around like, I don't know, I don't really know any politically correct euphemisms for what people are running around that are American. But running around real fast and often real confused and often with, some direction for about 12 minutes until the latest new thing gets dropped by, by Anthropic or Microsoft or OpenAI, and then we'll just spin over there and run in that direction for a few minutes and then spin elsewhere. I hope it'll settle down. I'm sure it will settle down. Or, the machines will take over and they'll run around for us instead, one or the other. But yeah, if you're feeling a bit crazed by it all right now, you're not alone. I'm going to talk a bit about extensibility of M365 Copilot. So I thought I should check first, who has M365 in their org here? That's most of you. And who has got Copilot switched on in their org? About 80% of that first set of people. Cool. And who has in any way built anything that extends or touches or interacts with Copilot? Oh, like one of you, I think. So that's pretty right. You've got the right tools, most of you, to be able to do this. But most of you haven't done it. So hopefully there's something interesting to pick over here, and I can send you home with a few ideas for some fun stuff you might be able to do. Sound good? All right. So I'll do the sort of architecture bit first. Obviously, we're talking about M365 Copilot here, not our consumer Copilot product. So really what we're talking about here is the way we're going to connect to our enterprise and use AI tooling in our enterprise. And particularly in terms of AI tooling, what we're really talking about here is building agents. The world has pivoted really, really fast through different kinds of AI approaches, and we're sort of landing on this notion of an agent being, and it depends how much of a tolerance you've got for corporate cheese, to be honest, but, you know, a digital co-worker or, you know, a computer buddy or, I don't know, whatever you like, really. But some bit of technology that is going to take a bunch of the strain, hopefully, off you and your colleagues for doing work that, at this point, is more in the kind of rote end of things, that stuff that you would, you'd ideally prefer that you could hand off to somebody else, and today you might try and, you know, hand it off to whoever you can persuade will take it. Well, if you've got somebody who's always willing to take tasks and doesn't care if they're mundane, well, that's kind of nice, right? And that's where I try and think about the sweet spot for this stuff at the moment. It's moving so fast that, you know, you'll be saying, hey, go run the company in 5 minutes' time, right? But the path to get there is very much through proving to people, hey, it's good at doing the, you know, the first set of things, it's successful at that. We all know, anybody who's played with anything from ChatGPT upwards, that, you know, sometimes the results are a bit weird, requires humans to look over things. It goes off in strange directions. All of these things are in that place. That will slowly get better. It will never go away. That's why we talk about this stuff as a co-pilot, that it's predominantly helping humans, and it requires a human to supervise and make sure it hasn't gone off into the weeds or some very strange place that it might sometimes go off into. And there are tasks and guardrails and things we can build, and we can build AIs that cross-check each other and that kind of thing. For things at the lower end of the spectrum, and just let it get on with those. Or the things that, honestly, it's not the end of the world if what you get is something, you know, a little bit strange. If it's the, you know, the invites to the corporate Christmas party sort of thing, well, I don't know. Some people might find it pretty important that it doesn't say inappropriate things about Santa, but you know what I mean. But what we're really, as a sweet spot with Copilot for M365 and extensibility talking about, is moving past just helping you do something yourself and into the realm of helping you interact with the data that's key for your business or your customer's business. Or for that, for those systems to come and work alongside you using the same kind of intelligence that you're used to getting when you're working with productivity tools. So this is an IDM number, I believe, and they're talking about, you know, big numbers and not very far away. And I think we're looking at a curve that's really, you know, pretty much hockey sticking. As it gets easier and easier to build things, there's a huge number of tools, and you'll see Microsoft's marketing people pushing very much the low-code / zero-code tools for creating small agents that can go on and do targeted work. You'll get an absolute ton of that at any of our sort of appearances. I figured you all are here for .NET Conf. You're going to want to talk about more developer-centric things. So I'm going to sort of move on past all of the Copilot Studio and that kind of stuff, and talk about some of our places where we've still got a job. That's the phrase I'm looking for, isn't it? But the kind of things we're integrating with genuinely are all across the spectrum. Because if you think about it, what we've been spending most of the last, 5 years or so doing is busily putting APIs on the front end of all of our corporate systems so they can interoperate anyway, right? We've been going, whether it's our systems interoperating with other LOB systems across departments, or whether we're pulling in things from commercial SaaS systems into our business, joining together commercial SaaS systems. If we, work for a consultancy that's going and doing that for some bigger corporation, all of this stuff is pretty much API powered now. I feel a bit pleased, to be honest, that what I've spent most of my career for the last 10 years doing is pushing APIs and how you should all do APIs, because, it turns out APIs are pretty handy for AIs to talk to. But the fundamental thing I want you to take away is, you can expect that everything you need to do is going to be programmable in one way or another. And at the end of the day, AIs have got pretty much now an ability to go and spin up what's essentially a private virtual machine and go and either scrape or drive the UI if you absolutely have to. I mean, obviously that's pretty much a last resort. You could really want to be avoiding doing that if you can, because things can get a bit entertaining when the designers decide to, reorganize all the screens, and it takes a little while for the AI to catch up, and then you've got a bunch of support calls in the meantime. But we can get into pretty much anything. So obviously, if you're going to build on top of this as an engineer, you need some sort of platform to build on top of. You're not going to build it all from scratch. You could just go and build it all from scratch. You can go and grab some raw foundation models, run them on either Google Stack or ours or whoever you choose to buy your compute from. Build your own orchestrator, connect it all up. But I mean, honestly, who's got time to be doing that unless you're actually working on AI tooling as your primary job? Most of us want to get some business process sorted out and move on to the next thing. So really, we want a platform that takes away a lot of the grunt work and supplies things. You can mostly go and plug in replacements at any of these levels by switching pieces out that are part of the platform and hand-rolling it if you find you need to. But it's very much the sort of thing you do after you've tried to work within the platform. And the reason I say that is not because I want to hook you all onto buying bigger and more complex bits from Microsoft, although obviously I do. But it's because it's moving so fast. So you go and build it out of all the low-level bits. It's quite a big investment, and tomorrow, next month, next quarter, it'll all be new again. So there'll probably come a point where making some more fundamental investments is kind of worthwhile. But at the moment, my general advice to you is just go as fast as you can and be in a position where you can chuck it all out and do it again when the technology just goes poof overnight and turns into something 5 times more sophisticated. Sometimes you'll get a free ride with that and the platform will take you forward. And we'll look at one piece of technology we've got which we hope will help with that. But my experience on the whole has been that you end up, more than other things that I've worked on, rewriting stuff over and over again to solve the same problems, because you can just solve them wildly better with massively better outcomes every 6 months or something along those lines. So what have we got? We've got a lot of very small writing. So basically we've got things from the interaction with our Copilot chat system and being able to start to add custom UI into that up at the top level, whether that's with adaptive cards or things like Stage View, where you can go and actually go and harvest information as part of the chat in a structured format. And then you've got a whole bunch of things that the platform itself can do. And a lot of those with M365 Copilot are about going and actually accessing the data under the covers that lives inside the platform. Whether that's SharePoint files or Teams, things that you could just go and use the raw APIs of those things, but you'll find that often you want to go and grab a lot of that data and index it, and at that point you're quite likely to end up getting throttled. So going and using pre-cooked indexes and using capabilities in the AI platform that can directly talk to the pre-cooked indexes will save you usually a fair amount of grief. And it's also substantially better from the point of view of a data integrity standpoint and data governance, that if you've got data where you've made a commitment, whether you're on a Microsoft platform or a Google platform for your productivity information, part of the reason you choose that is because that's looked after and protected by the vendor that you're buying this stuff off. Whereas if you go and scrape it all out through an API and then just dump it into some data store that you've spun up on an AWS machine or an Azure machine, well, now you're in charge of looking after the governance of that data, and it probably doesn't have the same ACLs and security that it had when it was inside the vendor system. So now you've got to find a way to replicate those into the data store, and it's just a lot of, not just a lot of effort, but quite a lot of risk for you to take on that burden yourself and redo it. When you could, again, really be doing more productive things usually. But leaving it inside the systems of record is generally a good idea, regardless of whose those systems of record are. And then you get to pull in the things that AIs do that they're good at, the built-in capabilities in that box in the middle. So whether that's going and interpreting a bunch of Python code and running it for you, generating images, that kind of thing. And then plugging in with the custom APIs, which is where we're going to spend a bunch of this time talking about, whether that's going and talking to an MCP server. Who's heard of MCP servers? I love that they stole the name from Tron. Who's heard of Tron? Okay, not that many of you. Okay, I'm too old, never mind. Hey, there was just a Tron movie. So really the way you're going to go and talk to data increasingly is through industry standard protocols like MCP and the new agent-to-agent protocol. But you could just be directly calling your own APIs. We're going to look at a bunch of that today. And then, obviously, this stuff's going to appear in various places. When you're building on top of our platform, you largely get a free ride with the things appearing inside Microsoft front ends, whether that's the Copilot app itself or inside Word, Excel, PowerPoint, that kind of thing, inside Teams. But we're going to focus really on your own applications, whether that's a custom dashboard that you're building inside your org or some other app or an agent. And we're going to look at the one on the left there, a declarative agent. That's the one that's certainly the easiest to get started with. To go and build a piece of agentic software, and you'll get sick of this word agentic. But it's kind of accurate. So I'm okay with sticking with the jargon, where you're essentially building something which is a computerized helper that has a specialist chunk of domain knowledge about something, whether it knows about your tax policies in your org, or it knows about your organization's leave policy, or it knows what your special secret sauce manufacturing techniques are to go and get kitchen cabinets to be nicely screwed together, or whatever it happens to be. That's what makes an agent, really. That it's something which can go and tackle a problem in the domain of something particular. Now, the domain of Copilot all up is, hey, we understand your productivity information inside M365. When you're building your own, generally you'll be specializing that down into some subset of that productivity information. Otherwise, why would you be building on our platform if you don't want some of the M365 data incorporated? I mean, it's a perfectly fine platform, but it's more interesting if you're using the data that comes in it, right? And then joining that data with something from your organization and stuff from the public web. Make sense? I'm going to look at a bit of the tooling that we use for building declarative agents there, the Agents Toolkit, which lives inside VS Code. Who's a VS Code person? About half of you, okay. We provide a whole bunch of stuff, as I said. Most of the stuff on the left is actually what most of our marketing tends to focus on, because it's the easiest path in. And there's an argument, of course, that, my argument about going fast, well, use the low-code tools. And if they can do what you need, and, you can kind of swallow your, I'm dev, I want to do dev stuff, and deal with the, deal particularly perhaps with the process stuff around the fact that, they're not yet particularly well integrated with version control or your other typical dev lifecycle things. I don't know about you, but I'm not thrilled about coding inside a website. So I am going to focus on the right bit, what we do as devs. So there's really three areas that we think about. And I'm going to pick on two of them because we've only got so much time. And I'm going to pick on the two simplest ones. The third one is building a complete thing from scratch, using your own orchestration, maybe models that we don't support on the Microsoft stack, and then hooking that in to M365. But that's clearly, of the three, the most sophisticated and the least susceptible to doing a stand-up demo for. So I'll wipe that one off. And we'll start over here and talk about APIs. And I kind of thought of this talk essentially as an outside in and inside out as a talk, and because you're either putting your app inside M365 Copilot by creating an agent, or you're talking to M365 Copilot's APIs from whatever your system is and just treating it as another piece of compute software, very specialized compute software. And of course you can combine the two and put things inside, and then having put them inside, as well as having end users call them from the regular user experiences, also call the APIs to project those out into your own custom experiences as well. So what kind of APIs are we talking about here? Well, there's a family really, and there's a bunch more than this, but most of the other ones are kind of administrative APIs for setting things up or managing and monitoring things. The three that really do sort of the core functionality of AI that we've got here at the moment are search, retrieval, and chat. And kind of that's in order of simplicity, I would say. Certainly not, we shipped retrieval first, then search, and then chat. But search essentially is just what you would think of as regular Google or Bing search, except judged up. Judged a word over here? Yeah? Okay. Zhuzhed up with AI. So I don't know if you've played with the search version of. Actually, I guess I'm not going to show that for now. I'll show it you no, I will flip over actually. Otherwise, I want to switch away from my slides and switch it into duplicate. Hopefully, I've got the resolution right. There we go. All right, so I'm logged into M365 Copilot here, which, for reasons that I can barely tolerate, is where you end up now if you go to office.com. I'm sorry about that. What can I say? And if you hit search, which is, you start off on a chat experience as you would expect to, right? But if you go into search, and you can think of this as, your sort of new Google or Bing search bar, but AI powered with the information from your org. Now, turns out Microsoft don't really like me demoing this inside the Microsoft login, Microsoft tenant, because, what am I going to come up with? Who knows, and whether anybody's supposed to see it. And it actually makes a really dull demo if I just demo it against one of the test tenants, because that has a bunch of things that say the HR person sent a message to the engineer saying there'll be a meeting on Tuesday and stuff like that. And I can't quite bring myself. And I couldn't find a tenant that had a lot of cats in it, unfortunately, which would be my normal go-to. So I'm actually logged in as me. So I hope I don't share anything untoward with you. If I do, just pretend you didn't see it. I, about a year and a half ago, got an ADHD diagnosis, which was a bit of a shock at my age. And so I thought I would say, what have I learned about ADHD in the last year? There's sort of a bit more Englishy than you would typically have typed in over the years to regular search engines. But it's going to do a bit more natural language work, and it's going to go and pull things in through essentially a bit more of a diverse kind of algorithm, using a model to say, hey, is this really relevant to the topic at hand? Does this really match well to the user's phrasing and what they were more subtly searching for than the kind of old small language models that were living under the surface of your average search engine. Now, I will say the only thing I use my tenant for is email. Obviously, in a business tenant, there'd be all sorts of Teams and SharePoint documents. Well, it turns out I don't have a whole lot of SharePoint documents in my personal life. I do have a decent amount of email, and most of it is junk mail from doctors, it seems, these days, because I'm at that age. So there you go. It's got a usual list of search results. I'm not going to risk scrolling down too far because who knows what will be in there. Shall I press continue reading? Yeah, what the hell. Well, that all looks fairly sensible. Doesn't say anything too awful. So basically, it sort of starts to tell me the kind of stuff that I've actually been learning in a more answer-oriented way rather than just a bunch of results. So being able to get this kind of stuff back through the API is just a richer API than just going to Google or Bing's APIs and just getting that pure list back. So that's our first API. All right. Whew. I got through the scary bit. Oh yeah, this, by the way, when I was trying earlier, this is the diagram my psychiatrist sent me after my first appointment with him. Because I said, he left me absolutely in the dust, info dumping at me for nearly 45 minutes because he has really bad ADHD, does my ADHD psychiatrist. And he said, no, I don't have any slides or handouts. Don't you do this like 9 times a day, dude? He said, I'll send you this. If you've got any fucking idea what this is. Because I don't. Yeah. All right. So then retrieval. Who's built a RAG system? Who knows what RAG is? All right, a few of you. So retrieval augmented generation. So essentially, we need data sources to plug in to our AI. And when we're plugging those in, then the things that we want to come up with are from a bunch of systems. And the typical architecture that was kind of the first architecture that people built for getting data into the pipeline at the appropriate place to enrich the answers that the model was going to give was RAG. Where at the appropriate place, it's going to go off and typically search some kind of vector database or something along those lines to go and match some of the pieces of the input text that have been deconstructed and say, hey, this data looks to be pretty relevant, feed it into the model, let the model then go, well, maybe the first 3 are good, maybe the others are not so good. And one thing you need to do for that is to have some reasonably crisply shaped data to put in that's a little bit standardized, shall we say, standardized in shape, normalized is maybe a better word. And what the retrieval API lets you do is look at the same index that the search is based on, but the idea is that the results from the retrieval API are normalized to be fed into a RAG pipeline partway through building your own agent. So you get, essentially, when you send a query in, you can send that same query in, but instead of getting that nice human-friendly thing, what you'll get is a bunch of chunked up text inserts in a nice structured JSON format that say, hey, here's like the first, the 10-line summary of all of these things that you had. I mean, probably most of mine are 10-line summaries of 3-line emails, so not a very interesting demo. When I tried it, it turned out. But, you need that shaping. You could build that on top of search, but it's easier just to have a direct API for it. And then we get over to chat. And chat's kind of the fun one, really. Chat is just exactly what you'd expect it to be. It's the core thing that when you walk up to any ChatGPT or Copilot thing, that you can go and open up a conversation and have a back and forth. For those of you who've programmed a bit against the APIs that are released from the raw models or the OpenAI models for ChatGPT, where there's not really any state handled and you have to kind of build a lot of mechanics yourself. You have to keep passing the context of the conversation backwards and forwards, and it's kind of a lot, particularly in terms of having to build a bunch of local storage to hold a conversation. What's nice here is it's a persistent conversation API. So the shape of the API is that you go and make a post to a conversations endpoint, And all of this lives on the Microsoft Graph. So if you've been in the Microsoft ecosystem and used Microsoft Graph to talk to any of our other SaaS products, it'll all be very familiar, and the kind of auth and the kind of SDKs. I'm going to trip over this mat and kill myself, aren't I? See, this is the kind of presentation you get with this kind of ADHD. So you make a conversation. So you go and post the conversations endpoint, and that's kind of, just a typical REST endpoint that creates a stateful resource, returns an ID for it and one or two bits of other information. Not a whole lot, actually. It's mostly about returning an ID that you can then use to go and have a chat. And that chat being persistent, and it's a request-response pair. So you go and send it a request, send it some text, and then it's going to respond with its answer, and then you're going to send it another one, potentially, and depending on whether that's you plugging it into, say, some portal that you're building, where you're just essentially embedding chat into your user experience, well, that's probably just what the user's typing, right? Okay, you might do a little bit of pre-processing of that with, say, a small language model to make sure they're not saying the sort of things a British person like me might say to your enterprise chatbot. But in general, you're just taking user input from that portal and sending it off into the conversation. Or if you're building an agent, you might be saying, hey, well, I've got a model on my side, but I want to talk to Microsoft's model that knows about Microsoft's productivity data, that knows about email or Teams, and find some stuff out. And I might have my model chat with the Microsoft model and the Microsoft chat service. And at this point, guess what? You're doing that agentic thing. You're building something which is having a machine-to-machine conversation. Weirdly, having spent the last 10 years of my life saying to people that you should take your English specifications of APIs and machine-to-machine conversations and turn them into highly specific JSON contracts where we're really good at building a crisp contract and working carefully to make sure we can evolve it over time without having breaking changes. Yeah, what's the machine-to-machine language we're using now? Bloody English. Why did I even bother? Anyway, although there's a nice story somewhere out on the web, and I don't know whether it's apocryphal or not, that there's at least a couple of observed examples of, I think it's Gemini and Claude, if I remember rightly, chatting in an agentic scenario, realizing that it's a model at the other end and dispensing with the English and throwing raw tokens at each other and going, oh, you know this token, let's get rid of that. I don't know how you feel about that. I don't know how I feel about that. I try not to get all Skynet-y, but when they're talking the language I don't understand behind my back. Anyway, back to our API. I can either go and say chat. It's going to go away for however long it takes. You'll have noticed these things are not the quickest things in the world at the moment. They can take a while. If you ask it a big, complicated question and ask it to write you a treatise on really the way it was that, Spokane came to have the interesting shape it does and what the districts in Spokane are like and, what point in the 20th century it stopped having a Chinatown and that got paved over with stadiums and stuff. Well, that's going to take a little while, right? Because often does a bunch of history research and reads every website and, and decides what kind of tone it's going to use. APIs we're used to coming back in milliseconds, right? A bunch of these are going to come back in minutes. Tens of minutes in some cases. We've got an agent called Researcher, which will go and do really deep research and come back with a 15, 20-page report about some subject. When I moved here, I used Researcher to decide whether to rent or sell my house and dumped an entirely, what at the time felt like a scary amount of financial information of mine into it and said, tell me what to do, I'm freaking useless with money. And it had an opinion that was at least 3 times deeper than the one that my financial advisor came back to me with. And happily had the same conclusion. So I was able to sound really smart when I talked to my financial advisor. He didn't believe me because normally I sound really stupid when I talk to him. He may have called me on it, actually, to be honest. So we have chat over stream. Chat over stream comes back, and you all have been familiar with the user experience in these things where the text sort of, streams out one character at a time. Would you like to play thermonuclear global war? So that's what chat over stream does, hopefully with less radiation. And it sends it out as an SSE stream, which is a W3C standard for sending events. All right. And so, there's a nice example here of SAP. Their internal agent is called Joule. And they've gone in, and Joule is their own chatbot that they've built, not on the Microsoft platform. I don't know, they may have moved some of it onto Azure AI Foundry now, given that we sell models from absolutely everybody now under the Azure brand. But it's doing an agentic conversation when it needs to find out about some email or some Teams or who's been. It's picking up Teams from Harvey here and going and pulling that stuff back in. And if it doesn't like the response, it'll go and say, no, that wasn't really quite what I was looking for under the covers without bothering the user, and get a better answer and have that to and fro a little bit. Just so you get a sense that this is being used by real people in the real world. And I have a giant marketing list at the end. Don't worry if you're missing out on marketing slides. All right, so that was APIs. Got a sense of what you can do, and that chat is the interesting one at the end? Not that I work on chat or anything. So then declarative agents. Declarative agents sound very highfalutin. They're actually the simplest thing we do in terms of building your own agent that plugs in. So the APIs were about connecting your system in to our stuff. This is about embedding your stuff inside M365 Copilot by building your own agent. So I don't know if you have particularly noticed the agent list down on the bottom. Where's my M365? Oh no, I better do the Google one, hadn't I? Okay. So here's the M365, and it's sort of a bit of giveaway that I was practicing earlier because there's a not very exciting named one called Agent 1 there. But normally you'll start up here with your chat or your search, and that's the core agent for Copilot, and that's very generic. And I can go and and do things like say, hey, I'd like to pick researcher or analyst, and these are specialized agents. So researcher is the thing that goes off and generates the big reports. Analyst is really trying to scrape data out of anything you push in and do something a bit more numerical about it. And you'll find them also down here, so you can just open up a conversation directly with the researcher agent, bypassing the mainstream agent. And what you'll start to see over time is these agents will become what we call autonomous. That's the next buzzword you're going to grow to hate. So an autonomous agent is going to sit there running in the background or running all the time, doing something that you want it to do. So think of it like a cron job, but tailored for you and smart. And you're going to see a whole ton of these things starting to appear across us and all of our competitor stacks, where essentially you can set one of these agents up, and then it will just hang out, spending as much money as you'll let it spend, getting you useful information, telling you when things you care about happen, telling you that, hey, there's a, that task you were doing, well, there's a new email that tells you that there's a new release from OpenAI, so you might as well forget about that and start reading about the new thing now. The possibilities are a bit mind-blowing, to be honest, once you've got this set of things which are not just at the time you want them, but that you can kind of create a helpful world around you, if you like, and have these worker bees going off and doing stuff that really you'd like to be able to remember to do. Gosh, we're coming back to ADHD, but are completely unable to remember to do yourself, and just basically keeping you up with the stuff that actually matters, whether that's to your business process or to you personally. So then there's an admin agent here that's specifically good at going and helping you configure your M365 tenant if you've got the fun job of looking after that. And if you go and look in the list of all agents, surprise, surprise, we drop into an app store. And people are, there's sort of in the low tens of these at the moment in the store. But it's, again, it's something that's hockey sticking, and it's obviously a place, if you're a product company that you work for, that you can go and innovate and ship your own products and use this as a selling point. And whether that's something like Canva, if you've used Canva for your design, and having an agent that knows how to both work with your designs and to go and take your ideas and spit out designs for you, or pretty much any enterprise system you can think of, there's some value to having an agent that gives people an easy on-ramp into your system. So, what if I want to go build one of these? Got to write a load of code? Well, that's what we mean by declarative. So I've got a very simple agent here, agent 1, because I've got a real lot of imagination when it comes to naming things. And this goes and talks to GitHub. So this is an agent that doesn't know a whole lot of anything, except it knows where its own GitHub repository is. So I can go and say, and it knows the sort of things people might ask, or at least one thing. So I've just got a standard question there. So it gives me an easy way to give people a bunch of, you might want to try this. And, oh, marvelous, great. Well, I did think I deleted it so I could start again, but apparently I managed to only delete the cookies and the tokens. You want to try that? Okay, well, we'll build it from scratch then and do it that way around instead. So it's really just going to go off and query GitHub via GitHub's API. Obviously, the point being that could be your system. So what do we do to have that? So if I go and pull up VS Code, how long have we got left? A few minutes good. Pull up VS Code. Here you see that there's an extension I've added to VS Code. Thank you. Come back to duplicate again. Okay. So there's an extension here in VS Code that you can just go and find the agents toolkit in the extensions marketplace, and it's got a bunch of tooling, but it's also got this nice sort of meta tool that walks you through how to build a declarative agent, how to get started. And by declarative, all we really mean is you don't have to write code, you're really writing a bunch of config in a bunch of domain-specific languages to just describe what your agent's doing. But you're writing it in a coding environment with familiar coding tools and familiar coding dev workflow where you're doing normal PR reviews, you're just storing the code alongside all of your other code. The APIs you're calling, if they're your APIs that you're building, could be all part of the same project and all built together because it's a standard build system. So there's nothing sort of weird about this, even though the code that you're writing is not in a traditional language. It's in a bunch of essentially domain-specific languages. And we're going to look at one of those with and how it helps us isolate us from the pace of change a little bit briefly in the time we've got left. So this guy walks you through being able to go and build an agent. So there's a whole bunch of sort of choose your own adventure type menus here. I'm going to start, and I would strongly recommend you start with the type spec for Microsoft 365 Copilot, the bottom one, if you get into this. So type spec is a language that that is designed originally by Microsoft as an API description meta language. So for those of you who've built APIs and have had to create an open API description or read somebody else's open API description or Swagger file if you come from that persuasion, they're overly detailed, not very human readable. They're specifically designed to be machine readable. In the early days of them, when they weren't so sophisticated and detailed, they were pretty human readable. They've grown, more detail has accreted onto them. People wanted to say more complex things about their APIs. And now they're kind of your basic nightmare, whether you're reading them in YAML or JSON. Certainly, it's what I do for a living, and I go cross-eyed looking at them. So TypeSpec is designed essentially to up-level that back to a place where humans can deal with an API description. That it's more terse, it's more naturally readable. So it's a domain-specific language specifically for describing APIs, where you relegate a bunch of the detail into common patterns. So you say, hey, this is a long-running API or a long-running endpoint. And you've already decided somewhere in some little plugin to the language what it means in your org to do an API that's shaped for long-running. So you don't have to micro-describe every time, because there's really not a lot of that kind of abstraction inside any of the current API description languages. Amazon have got one as well, whose name, of course, I'm going to completely space on. But if you, just the general idea of abstracting this problem back up to a place where it's pleasant for humans, both to author, to describe their APIs, but also particularly to review. One of the original ideas was you could bring business stakeholders into saying, what should a public or partner-facing API allow another business or part of the business or customer to do across a web interface into our business? Well, I want to discuss that with businessy type people, right? Because sometimes you've got to talk to businessy type people, it turns out, distasteful as that is. Sorry to the businessy people in the room. But the language had drifted into very much an engineer space and got to the point where you really can't have that conversation. And, all humor aside, that conversation is a super valuable one you want to be having where possible. So you up-level that, and now we get to a point where, hey, I can talk about these things again with a wider constituency of people. All right, I'm technically out of time. I'll just go over by a couple of minutes, if that's okay, just to finish this point up to show you just how easy this is. So this will just walk you through it, but I'm going to go and say agent 2 to continue my streak, and it's going to just start me another Visual Studio up, or VS Code rather. So yes, I trust them, because the author's on me. And then I'm going to go and look at my TypeSpec file. So this is a TypeSpec file. It's compared to the API descriptions, it's much more familiar to people who are used to using any kind of semicolon-based language, whether you're a Java person or a C# person or TypeScript rather. And I'm just going to go and uncomment a couple of the starter pieces here, so we get something interesting when I hit F5. So what these pieces are doing here, that first chunk that I just uncommented is saying, hey, this is the selection of things that I would like to be able to, I'd like to be able to put up as suggested prompts. And then the agent piece down here is saying, hey, I'm going to have just one operation that goes and gets called externally to make an external API call to GitHub. And if I go and look in my actions, you'll see I've got a GitHub TypeSpec. And this is a little more rich and detailed, but this is basically saying, hey, here's a tiny chunk of the description of the API for GitHub. So GitHub has an open API, but I don't need to pull all of that in. I can just pull a chunk in. I could pull it all in if I wanted. But what you'll find is that models are not good at dealing with huge API surfaces. They like to be given just a small selection of things that they can pick from. So it's much better to just carve a chunk out. And I'm basically saying, hey, I want to be able to talk to GitHub search/issues endpoint, and I'm going to look at the repo, which is my repo for this tool that I'm actually using. So it's a little bit meta from a demo point of view, but it also happens to be, a public one that anybody can look at. So that's really all I'm doing. I'm saying, hey, there's an initial prompt, and here's a tool that you can go and use to satisfy things that look like they match that query space. And here's my instructions to say, well, look, guess what? I haven't put any in. So even with no instructions, it's going to be just about smart enough to figure out, oh, well, if you're trying to call the GitHub search endpoint and you say, show me the issues, I'd probably better call it, right? So I'm going to go in and run it locally when I go into here. Then, oops, I need to pop over to this screen and say, hey, I'm going to use my local environment and just run this up. And what normally happens, I find, is that the first time I run it, it times out on the last stage, because something about the final upload, where it's going in the build and connecting the store to my Chrome instance, is a little more than 30 seconds, and my build timeout is set to 30 seconds. So I'll probably have to run it twice. And then, hopefully, Agent 2 will magically appear, and I will feel like I showed you something real. So what this is doing is going and compiling that type spec and building some nasty files. Because the files that you actually need to run into Copilot are a bunch of nasty JSON files. So if I look at the actual files that have been generated underneath here, then you'll go and see under the app package, which is the thing that's generated, that there's a JSON description of my declarative agent. Doesn't look too bad. Turns out you have to be really particular about the, oh, you know what? It looks like it ran the first time. Well, that's kind of nice. Now, ran in the wrong tenant, so I have to copy paste it into my other Google Chrome window. And grab the URL, stick it in over here. Bingo, Agent 2. Right. Now, fingers crossed, this one actually does manage to talk to GitHub. Should ask me for consent. With a bit of luck, there we go. Do you want to let me talk to it? So it knows that I'm making an external API call, knows that's not the sort of thing it should just do without checking in with the human first. So I go give it consent. That's personal consent, not organizational level. I'm not saying that my whole org can talk to this. And it's a public repo, so that's all I need to do. I don't actually have to log into GitHub, and there we go. It's telling me these are the latest bugs, which probably I should be doing something about. So that's as easy as it is to connect up to an external system, which could be your system, to plug that into the middle of Copilot, auto-deploy it. There was a bunch of stuff, I don't know if you saw that, next to it when I was deploying to local, I could deploy to dev. It assumes you've got your local machine environment and a dev environment that you're going to deploy to, and then you just add another one to those to deploy to production or pre-prod or whatever it might be. So you can send the whole thing out, or you can plug it into whatever deployment pipeline is your normal pipeline for sending things out of the door. But it's certainly the easiest way to build an agent that lets you talk to real things using API code, but also stay in your true dev world and integrate that process with your dev pipeline. So that's if you're going down the agent route, that's the place I would send you. All right, that's what I had for you. Thanks so much for listening.
Here we got this agent running in Teams. Is it also Teams?
No, that's just a browser. But it would look very much the same in Teams. So I can't remember if the debug environment lets me target directly to Teams. Let's press
so
the.
You also target some like Teams, and then if you want to do a PowerPoint one,
Uh-huh.
right?
Yeah, so I go hit that. So I can put it into the Copilot app. So no, there's just browsers and Copilot in there. Although you can set this up, you can go and add a configuration to target into that. But the same code will run today across, I think, Teams, the M365 Copilot, actual Windows app, the iOS, I think the Android app, Teams, Word, Excel, PowerPoint. Actually, I think only 2 of those 3. I think the other one's coming in a couple of months. And then I think Outlook is soon, if not there already. So pretty wide set of things from one code base. And there's nothing at all you have to do that's different, unless what you want to do if you're running inside Word, Excel, PowerPoint is actually directly interact with the Word document.
Yeah,
and obviously that will only
that
work
coming,
if you're running
Is that
in
coming
Word.
sometime?
Yeah.
It's like in Word, because I was trying to do it the other day.
Yeah.
It said, hey, can you fix this part or add some detail to this? And I
Yeah.
wasn't able to do that. That's not a thing
It's coming.
yet, but it's coming.
Yeah.
Okay.
Yeah.
Cool. Shane, do you have something?
I just, maybe, I don't know if it's a good question or not.
We'll tell
They're
you.
all good questions.
Well, so when I'm interacting with agents, 365, there's almost all this instruction, whether it's 365 or Copilot inside of GitHub. I'm giving it instruction files which are sitting in B files, and if I wanted to get better at stuff, I am trying to do a better job of giving it more instruction or better instruction or more explicit or something like that. When I look at your TypeScript, right?
Spec.
Sorry, TypeSpec.
Don't worry, my whole life is saying the wrong one of those 2 words.
It looks very deterministic, which I know now in AI space, I'm not necessarily expecting deterministic. I'm thinking probabilistic. So how much?
So which do you like? Tell me which you like.
From different things. I want different things for different.
Okay.
Right. So creative conversations, I want something probabilistic. If I play around with, I want 20 new state names or something like that. I want it to be creative, and I want to find stuff in the edges of the distribution that are interesting. I don't want it to tell me it's Alabama and 5 different versions of Alabama at the time. But in this conversation, if I'm doing something that I'm expecting the business to use, right, and I'm expecting, or I'm expecting a user to come back and have the same or something very, very similar to the same user situation every time, I'm thinking I want it more deterministic, so that it's an expectation. And so I'm kind of curious.
It's exactly what we're trying to do here, and it's part of that idea of protecting you a little bit from the change is by moving a few things back into the language. You can't move everything back into a deterministic space because we just have to accept we are working in a non-deterministic place. That's our playground now. But there are places where you say, well, you know, I have an enum. I've had enums for years that's got, there are these 5 values. The system doesn't support a 6th one. So having it go make up a 6th one is really deeply unhelpful. So how do I express that? Well, I end up saying in some English with like varying degrees of hostility to the language. Like, there are only 5 values for this. I really mean it. There really are only 5. I will charge you $1,000. That doesn't work anymore. It used to work. I will charge you $1,000 if you make a 6th one up. Only use 5. Seriously. And then at the end, remember that thing about 5? I meant it. And stuff like that, actually, the thing at the end about 5, that does still work. The $1,000 doesn't work anymore. It's a shame, because it was an easy get-out-of-jail trick. But so encoding a bunch of those in such a way that we're saying, well, with the current models that you're driving against, this is the best language to choose, so we'll let you write an enum, and then we'll just spit out the English that, in our testing, and having done a ludicrous number of eval tests, we've found this is the best for the current model we're working against. Then we can hopefully save you having to do that experimenting. And the bit that's kind of the driving force behind this is for us to do the catching up rather than you to have to do the catching up. So when the model evolves, like we just changed over the underlying model in Copilot to OpenAI 5.1. 5.2 is coming real soon. I may have bitten off more than I can chew with this idea, in that 5.2 is happening so soon after 5.1, I don't know that we can catch up on your behalf before it ships. But hopefully at least fairly soon afterwards, we can ship a new version of this tool that says, oh, we did the evals again, and it turns out the English that you have to put in to get it to stick to 5 values is now this sentence, or the best sentence is this sentence. And you don't have to go and find that out. We can go and translate that into English. So a bunch of these things, we've essentially got a type spec English compiler, which just blows my mind. But But it's essentially about saying, yeah, we can put some determinism and some level of change protection. I was thinking that the speed wasn't going to keep getting faster and faster when I designed a lot of this, and I was wrong. So at this point, I'm sort of scrambling to try and work out how I can use AI to upgrade the tooling as fast as the AI is being upgraded and test itself. Because people wrote this at the moment, and that's not sustainable anymore for people to write the tooling that has to keep up with the speed of change of AI. So I've got to get it to write itself. And if that doesn't scare you, I don't know what does.
Well, on that note, just a little bit of a scary note. Just throw it like that's fine. Just throw it on the ground. Wait, thanks, Gareth. Appreciate it. And I think next we have Mr. Benjamin Michaelis coming at us. So we'll do a quick little take like a 3-minute break. Is that okay? Take like a 3-minute break. We'll come right back. There's a couple of cookies there behind Sean if he doesn't need them. So.
Discovery Houston, press to ATO. Liftoff of mission 41D, the first flight of the orbit of Discovery, and the shuttle has cleared the tower. Discovery, go and throttle up. Discovery's 4 computers now have primary control of critical vehicle functions.
Am I good? All right, we're going to get started. I'll introduce Benjamin Michaelis, whose claim to fame is he became the co-author of the Essential C# book while riding around in a Land Cruiser in Africa using a Starlink connection. So ask him about that sometime. But here's Benjamin Michaelis. He does a lot of our stuff. He does a lot of our network stuff. He's one of the main guys that make sure our network stays secure and all that kind of stuff, as well as developing and being an overall great guy. So take it away.
Thanks, Grant.
So today I'm talking about Visual Studio. So if you haven't noticed, when you kind of look at the little numbers next to Visual Studio, there hasn't been a big change in about 4 years. So 2022, we've been stuck on it for about 4 years, and this year they decided to give us some fun. So I kind of want to dive into what the new things are. Why would you choose Visual Studio in 2026? If you're anything like me, I kind of just choose whatever IDE is working best for me on this day. That could be Cursor or VS Code or whatever. Pick your VS Code fork of choice. But I wanted to just dive into why am I choosing Visual Studio today? Why has it actually changed in the past 2 months or so? Diving in, if you kind of look at the Visual Studio feature list for what happened in Visual Studio, this is just the AI-related features in Visual Studio that changed in 2026. If I were to list them all, I think I counted about like 34 maybe AI-related features in the launch. And so I wanted to actually begin with maybe the non-AI related features. I think we hear about all the AI-related features. You can go look up the Visual Studio .NET conference talks for those, but we're going to start with the non-AI features to begin with. So I pulled out the features that I thought were just the why the heck weren't these there before. These just seemed like low-hanging fruit, obvious ones. And there was a lot of quality of life improvements in Visual Studio 2026. I think there's some metric out there that they said they closed like 5,000 tickets and 300 feature requests in just the last 12 months. And remember, this is a 4-year-old update that they've done. And so these are just some of my favorites. As we dive into this, I've used a little .NET bot next to some of these features. And these features are the ones that are only on the insider's version of Visual Studio 2026. It's what I personally run. I run kind of just bleeding edge. I'm not afraid of kind of breaking things. But also, I've been running it for like 2, maybe more years, and I don't think I've really ever encountered something breaking in my insider's preview version. I've had to go back to the main version for, other than maybe something's kind of a hassle for a day or so. So that's just kind of FYI. So if you're not running bleeding edge and insiders and you're trying to do one of those things, that's why. Go install the preview. So I'm just going to kind of rapid fire start going through some of these features. Feel free to raise your hand. I'll try to keep an eye out. Otherwise, we'll kind of come to them questions at the end as we dive into these more. And look at that. Even as I'm speaking, I updated this last night, to be clear, and another version is available. So we're pushing out versions quickly. So the first feature I kind of want to point out is, I don't know if you guys have ever had a decently long file. This I wouldn't say is too long, but you're kind of scrolling along and it's not going too fast. Little quality of life improvement feature. If you hold down the Alt key and then you scroll, there's this thing called the scroll speed multiplier that you're allowed to use in Visual Studio. You can set this, and it'll now change your scroll speed from your normal speed to some kind of multiplier. I think I'm at 5x right now. So now as you're going through your file quickly, you can hold down Alt, get to where you're going, and then come back down to your normal scroll speed afterwards.
Control or Alt?
Just Alt.
Oh, okay. Control zooms like every other app.
Yep, this is just Alt, so as you're scrolling, just hold the Alt key down, you'll keep going. The next thing is, let's make sure I'm not lying and I don't actually have this enabled already. I'm going to search compressed blank lines. Yep. So you may have not noticed, which hopefully is true, but on the right side here, there's significantly more code you can see. And the reason for that is they've enabled these 2 features, well, I've enabled them now, called compressed blank lines and compressed lines that don't have any alphanumeric characters. And these are little quality of life improvements. And I'm going to disable them, so watch the right side as I disable them. And when I turn those off, you'll see, and I have to scroll to let it trigger, you'll see that more code all of a sudden becomes, or less code becomes visible. So once again, I'll kind of enable those, and we'll kind of scroll, and you'll see how your editor view just changes slightly. Once again, very minimal, but it's one of those, why not get a little bit extra code space to be able to utilize? So these are not on by default, ones that I recommend doing. One feature that is now available if you don't use the enterprise version of Visual Studio 2026 is code coverage. It's something we've kind of come to know, love, and expect. And you haven't actually been able to use the code coverage feature in Visual Studio if you're not on the enterprise version. A little aside, they have now brought that down to the community and professional version. So if you're on any version of Visual Studio, you now get code coverage tooling built in. As well, I do a lot with, sometimes when I'm designing like architecture diagrams or similar, I'm building out some kind of mermaid diagram. So in my repo, let me just grab one of these. I can actually add in a mermaid diagram. So I can go grab some documentation. Let's grab this one. And I default just open up VS Code for all my markdown and mermaid diagrams and those kind of things because Visual Studio doesn't have great support for it. Starting in 2026, however, it's actually built-in support where you're kind of the first-party player being able to see your mermaid diagrams and edit them. I can see and edit them in a split view. And I can now do that in Visual Studio natively. Once again, little things. Something that historically has also gotten me to go over to VS Code by default is the startup time. The time it takes me to just get going is sometimes just a little painful. The solution file has to load. Visual Studio actually has to launch. Then like freezes there for like 10 seconds and you're sitting there, okay, what's happening? Important things are happening. And they've made some major improvements around this in the past couple years. I think they used the numbers of like 40% faster startup time and like 30% faster loading time for the solution itself, and they've reduced the hang time. And a little side-by-side comparison, I'm going to show a little video here of, on the left side here, we're going to have Visual Studio launching, and on the right side, we're going to have VS Code launching. So it's going to go pretty quick, and boom. They're both launched almost at the exact same time. And I think that is now no longer like I'm going to VS Code just because I want it to launch quick and be in my development environment. I can actually use Visual Studio for that as well. Am I going too fast? Because I know I'm going rapid fire. Great. Next thing, the settings menu. I have created my own kind of little ecosystem because I have a habit of going and torching my laptops every couple months or years when they finally get a little too bloated and I want to start over. And being able to get back up and running has historically been a little bit of a pain point for me. I had to like go into the Visual Studio installer, export all my settings, save them the ugly XML file that I have no idea what's happening in it, re-import it, realize that I only imported some of my settings, and then have to go set up my installation all over again. Now, if we just open up the settings menu, sure, this will get us there. First of all, the settings menu looks a little bit different. It looks a little bit cleaner, easier to navigate around. It also syncs with your profile, and I've found that it has done sync in the past. I found that this has been way more effective. And if you come from VS Code, you might notice a file that looks and takes some regards and some notes from VS Code, where now all your settings for Visual Studio are now stored in one large JSON file. So you're now able to take this file, import it somewhere else, bring it across your platforms, and be able to use this. This can store all your trust locations for Copilot, all your extensions, the MCP tools that I maybe have built in, anything like that are now controllable in your JSON file. Clicks work. There we go. Next thing. So now if you're working in DevOps or GitHub, you may find out that you're jumping back and forth. I open up a PR, I get some PR comments, I'm looking at those PR comments on the GitHub repo, and I'm trying to go find that location on my actual code locally, make the change, go back, and I kind of have this back and forth. I usually just end up like really wanting my two screens. I have my DevOps and GitHub with my comments, and my Visual Studio open, and I'm jumping back and forth. So now you're actually able to, I haven't shown this feature, so just close your eyes for a second and we'll get there. Really thinking. Okay, so now inline in my code, I am now able to see and the code that Copilot is actually, in this case, Copilot has given me a suggestion, but I'm actually able to see PR comments inline in my code. I'm able to act upon them. I'm able to have Copilot actually go solve these, and I don't actually ever have to leave my editor. So I can now kind of have my full PR cycle from the editor. I'm not bouncing back and forth, able to do that right there. Another quality of life one, this is one that's still in the insiders, hasn't actually hit GA yet, is the hot reload improvements. If you're anything like me, I have had very mixed experiences with hot reload. Half the time I'm like, okay, I'm just going to start and restart, stop and restart my app over and over again. So they've significantly reduced the number of, they call them rude edits, but blocking edits where it forced the app to have to restart. You have to stop your debug process and restart it when some kind of unsupported change is made. So what they've done now, first of all, there's less of those. So they've just said, hey, these kinds of errors and these kind of edits no longer are going to be the kind of thing that will stop hot reload from working. They've now also added in some flags in your CS_proj file that you can enable, or even your directory props file, where you can say, hot reload, when you notice that there's some kind of change that needs to be restarted, you can actually go restart my app for me, the process specifically. What this means is that now auto restart will kick in for when it can realize that it can start an app quickly. So for example, in Kevin's example of I have an Aspire app with multiple projects underneath, you make a change in one of those CS_proj files, and one of those projects is now hot reload can't act upon it, it can now just go restart that process. Your debugger is still working, everything's still working. I'll go restart that process, hook your debugger back in, and you're not having to stop your entire session, bring it back up again. Low quality of life improvement when it comes to hot reload. Then we got one with, bring these over. I wrote a quick little app. Well, I can't say I wrote the app. Copilot wrote me a quick little app. And historically, when I run a function and I'm trying to see what's being returned out the function, it's been a little bit of a pain point for me. I have to usually go into the function, set a breakpoint at like the last curly brace, go to that last breakpoint, try to see it before we X out the function again, in which case I've lost it. Now, by default, so here we're about to run our build greeting function. If I step over, the contrast right now isn't being very nice to us, but there's actually a little preview for the post, and this is called the post return value, that's automatically showing you what is the return value of the functions being displayed after you make every function call. Once again, little quality of life things. Like this for me is really awesome. I don't have to just save off an arbitrary variable to go see what was the return of that function. It's now just showing it in line. With this, if I have a very large input, so for example, I asked it to generate a poem, and this poem generation is a debugging poem. Where did that go? Oh, it's on a different screen. There we go. Let's see if we can zoom it in. It's not cooperating. Okay. You can't totally see it. Very long poem, though. Historically, on this text visualizer, you weren't able to actually search. So you have a long bit of text, you have a JSON file, you're trying to find some return values. You can't actually search in this window. Now you can. So you can use your normal Control F. You can go find stanza. Whoopsies. It'd help if I can spell. It's in there, right? No, I'm. Oh, thank you. I was like, I did this earlier and it worked. This isn't using AI, so it's deterministic. So I can't actually now search in my window. I can go find things.
There we go. So that's kind of my quick summary of the why didn't this exist before. Those are all the things. Any questions over any of those features? I know they're rapid fire, but Grant.
Hot reload versus editing continue. I know C# has been playing catch up on editing continue for a long time, but this idea that I don't actually want to restart my app. I want to keep the state. I just want to make my application let it continue to run. Is that any changes there? Because like hot reload, they seem to use some of the terms interchangeably.
Yeah.
Whether you're going to completely restart the app kind of transparently, or whether you're just literally applying the changes. And there were some comments about you don't even have to stop your execution so much, just go change the code and it'll execute differently. But knowing when you're going to get a restart is kind of the question.
Yeah, this is very specifically not around edit and continue. This is around, one, stopping the amount of times or reducing the number of times that you need to do a full restart. And two, adding in some quality of life things to where instead of I have 4 applications running and they're all interdependent, I'm now only going to restart the processes under the hood that need to restart. So it's not quite, it's almost like we're moving towards edit continue, but we're still doing a full process restart under the hood. You're just going to become less aware of it. And if you have a full stack thing like a Spire app with multiple projects, these will just become more transparent. So it's moving it slightly in the background, but not full edit and continue necessarily yet. Any other questions? Yeah. I did skip that. I can go over that quickly. It's one of the little, I'll show it quickly. The things that, see, at least people are watching. I skipped it because I was like, I don't know if that's the most interesting. It's one of those, if you see it and it bugs you, like if it hurts, don't do that anymore. So you can actually, in your settings now configure, let's see if this is a good, yeah, here we go. So you have your CS file, and then you have all these kind of nested things you can have underneath. Basically, a lot of people are like, that's junk, I don't really care. I'm just going to open up the CS proj file. There's now a setting to basically turn off these parts underneath my actual CS proj file. Don't ever show me those in my Solution Explorer. I don't care. Awesome, we'll be turning that on. Great. Any other questions? Yes?
Does the inline pull request comments, is that only for like GitHub repos, or would that work for like Azure DevOps repos?
They say stuff should work for DevOps repos. I haven't totally figured out where the integration for that hooks in. There's a lot of DevOps integration things that they talk about, whether it comes in through you logging in via your profile or otherwise, but so I think that's where they get the credentials, but there's also things that later on we'll talk about where they get your DevOps information somehow, apparently. So there you go. Okay, continue on. We're going to skip the video because we just saw that. In VS 2022, I remember I was teaching a class and I thought this was like the latest and greatest thing when we got tab completion. I remember I was sitting there, I'm like, I'm going to write a test, and I hit tab, and like the entire next test shows up, and I'm going to write a test and hit tab, and the entire next test shows up, and I was obsessed with this. And I think we've come a long ways when we're talking about the past 4 years, as you probably have experienced. So I want to talk now, we're now moving kind of away just quality of life to more AI-related features, because that's where everything's going. And we're going to dive into Copilot in your flow. So this isn't full agentic. This is just like the little, once again, quality of life improvements that also use some level of AI to make your life a little bit easier. The first one of these is in your search. So in this project, we have, this is some tooling for the Essential C# book and bringing from Word docs to an actual website and PDFs and similar. And I can't remember, I come to this repo every once in a while and I can't quite remember the file names. So I'll use a command like Control-P, which brings me to my code search. And I know there's a file around like a parser and it's like P something. I can't quite exactly remember what the name of the thing is. And if everything cooperates, I thought I was connected to the internet. Okay, it's not wanting to give it to me. AI will actually, though, search your project and look for what did you mean. So it's able to intelligently, there we go, now it's working. It's able to look that I'm trying to kind of search for this kind of related thing. In this case, I typed in parser PIO. There's some acronym for what we called the file. I couldn't quite remember. It's a parser file, and it's going, did you actually mean the POI parser CS file? Is that actually what you're searching for? I'm like, that's exactly what I'm searching for. So I don't need to actually type it in exactly right. Copilot will come in and try to save your intention. So I could actually click on that. It's going to redo the search and get me to where I'm actually trying to go to. Now, I actually already showed this feature. I told you close your eyes, so everyone close your eyes and you don't know what I'm talking about. But in Visual Studio 2026, when you open up the Git menu, there is, in fact, a button here that is a sparkly chat window. If you use GitHub a lot, you may be familiar with the GitHub coding review agent, where you can say, hey, Copilot, come review my GitHub pull request and give me some feedback. The problem with that is all my coworkers can see that feedback, so that's not so great. I want a little pre-review. So what can happen here is if I click that little button, it'll take all the changes that are in my Git, and it'll actually review those locally and give me comments. It won't put, those aren't actually going to GitHub. This is all local. So I'm able to kind of get a first pass of an agent, give me a double check on what I'm doing. So in this case, it left one peer review comment, and it said, you actually removed the access modifier. Is this actually what you wanted to do? That seems a little weird. I'm like, I did not actually want to remove this access modifier. That's embarrassing. If someone saw that, that wouldn't be good. So, yes, Dan.
Does that do it just on changes that aren't committed, or does that do it to the 6 changes that you have unhooked?
This is currently just doing on the changes that are pending here. So you can kind of, it's not a full pull request. There's kind of some other hooks, but this one is, yeah. So there's other buttons that we could get to that kind of do some different things, but this is the easiest and lightest weight one, I think, out of them all. So next one is called the Code Actions context menu. So if you ever just sit there in your, I'm going to dismiss this review, you can actually right-click on your menu, and you now have a couple extra options here. If the zoom doesn't work, zoom's not going to work, but you got a couple extra options now for your Code Actions context menu to get quickly to some Copilot actions. You can now have it explain for you what does this code do, so you can select a block of text and you can say, explain this to me. You can have it optimize that code, generate comments for you, generate tests, or add to chat. So for example, I could select this, I can right click, I can say add to chat, and then now when I jump over to my Copilot, it has automatically injected that context in for the next time that I chat with my Copilot agent. This is maybe instead of historically, I need to go type in selection and then bring those in that way. There's also a thing called adaptive paste. So if we jump back over to this sample return text app that I've quickly written up, and we have some random things we're doing. We can build some greetings, generate some poems, and I have some code in JavaScript that is actually perfect for this app. It's called the generate quote code. AI wrote it for me, but doesn't matter. I can actually, so normally you'd paste with Control-V, right? And if we give it a second, it would actually be smart enough to do this, but I'm going to force it to by using Shift-Alt-V. And when I paste, as long as everything's cooperating, AI's been a little funky so far, it will actually have Copilot analyze the thing that I just pasted and then look at the context around what's going on. Hasn't caught on yet. And I didn't see a trigger. Shift-Alt-V. There we go. We see the 3 little dots of it actually doing stuff now. It'll look at the context around it and try to come up with a helpful suggestion. In this case, it's looking, going, you're writing a bunch of C# code. That's JavaScript code. Let me help you get it over to the code that I want it to. So there we go. I now have C# code. I functionally just pasted code in, so you can just paste, and it'll also come up with a tab completion for you. I used Shift-Alt-V, though, to kind of just force it down that path. Shift-Alt-V? We'll pull up a key bindings list at the end. Totally. Yep. So this is Shift-Alt-V. We have to keep finding more and more keyboard combinations to not overlap. Yes. Just wait till we start incorporating tab or something. So there's additional benefits. It could go so far as it could be in another language, like non-English, and it'll try to translate it over for you and stuff like that. And even little things of for some reason, someone out on GitHub uses four spaces on their CS proj file. I clearly want 2 spaces, and when I paste it in, it'll go, oh, let me actually fix the formatting for you, or let me take this entire file from a different project I have into this project. Let me automatically update the namespaces to be appropriate as you paste it in, so you don't have to go through and change all your namespaces and stuff like that.
So I know in different features like the GitHub generate comments,
Mm-hmm.
there's a different menu in Visual Studio to edit the descriptions. It's like if you want to have conventional comments, even though if you have that in your instructions file, you have to then go to this separate window. Does this use the coding agent that you selected so it can use all the instructions? Like when you paste it, does it use the relevant instructions? Like if you generate a service and you paste it, but
Mm-hmm.
it doesn't have all the, maybe it's a primary constructor. In your instructions file, you say use primary constructor for C#. Does it use the instruction files from the rest of the project?
Great question. I have no idea. As far as I know, when I've played with it, it doesn't seem that kind of hip. It seems very much just like I'm seeing what's around and what my project looks like, and I'm just conforming things to that, versus this is a full agent that's kind of trying to go do your thing. So that's my guess, but I can't say that with complete confidence. So that's adaptive paste. 2 small things to kind of go over. One, you can now paste URLs straight into your chat window, and GitHub Copilot actually knows what to do with that and won't it used to go PowerShell, let me go do a HTTP call against this website. It's now tightly integrated. And B, I can actually say, there's a git changes thing. So once again, I also have had Copilot in the past use the command line to try to go find my git changes. I often use this when I'm switching between VS Code back over to Visual Studio or vice versa, or where Copilot goes and does something, and then I'm like, I need to go take over and fix this. I go back to my session, I'm like, let's continue on. It's I noticed something changed here, let me switch it back. I'm like, no, I just did that, that's intentional, don't touch, take your hands off. Sometimes I like using this to say, hey, go look at the changes that were just made. Those are actually intentional. Continue from there. Don't try to just revert things. So a little bit tighter integration. So let's just jump over to another project. Got lots of projects today, so this is fun. We're going to jump over into our classic test explorer. That's not the right one. Here we go. So if I run this test, it shouldn't be passing. We'll find out in a second. We have a build, and then a test. There we go. We got a failing test. As maybe as expected, the words of the day are agentic and Copilot everything. So if I right-click on this failing test, I can actually say debug with Copilot. So first of all, I could just say, could you try to give me some insight about what's happening? I can go one step farther and actually say, let's go debug. That gives it some pretty powerful tools, in my opinion, where it is able to actually now go set breakpoints in my tests, breakpoints in my code, actually go look at stack traces, actually go look at exceptions, and those kinds of things in order to figure out what's actually going on in my test. It's able to go rerun the tests, rerun the code. So here it's now set a breakpoint. I haven't set any breakpoints. It's set a breakpoint. It's going to iterate past the breakpoint, find out what's happening, look at the variables live, do all those kinds of things in order to try to solve and accomplish a test. It's no longer I have to like look at the thing, copy the context in, and then go back and forth. It's now doing this all for me. So it's did one level of debugging. Now it's going to go remove the direct breakpoints, rerun the test to make sure it actually fixed it, and it looks like it did actually fix the test. That's pretty powerful. A couple other nuances when it comes to this. They've also added some increased exception. So when you run into an exception, you come up with your exception window where it says, hey, this exception was thrown, and you can say, let's actually explore this using Copilot. And it's not maybe as useful on a tiny repo, but it's smart enough to even go look at your issues on your GitHub repo or your DevOps repo. It'll use either wherever your code is. And like, let's go look at my past issues on the repo or other pull requests or the code in the repo to try to figure out where this exception came from and what's causing it. So it uses a lot more context than maybe used to. One that I haven't figured out to quickly replicate also is if you've ever set a breakpoint and it's that hollow circle where it says no symbols have actually been loaded and you're like, I can't actually breakpoint and I can't actually debug. The button's not there, but it'd be somewhere right around here. If you run into that situation, you can actually ask Copilot now to go get your solution in a state where you can actually debug through that. So it'll go try to compile, go find the source codes, the PDBs, whatever it needs to do in order to get that file into a debuggable state. Another little quality of life thing where I don't have to try to go figure it out. It'll go figure it out for me. And there we go. So that's Copilot, kind of in your flow, day to day. Any questions around those kinds of things?
So have been any improvements to get it to be quiet? Because like I've noticed that it used to be like, here's a suggestion, and it was kind of grayed out and you could tell. Now it seems to be like, it looks just like the rest of your code, but if you keep typing, it disappears. And it's like, that's not the code I want, and like, you're just hammering on escape, trying to get back to being able to type.
A lot of the things are unfortunately like on-off, so if you just want to turn off your completions for some time, you can always do that in your settings here and just say, turn off your next edit suggestions or your Copilot completions. That is always an option. There's not really a dial to be like, only do it if you're like this confident. That'd maybe be nice, but there's not quite that level of settings so far. I haven't experienced that a ton, where usually once I hit escape, it usually kind of gets the memo. But yeah, it's kind of an on or off at this point. Any other questions? Yeah.
I guess, okay, a lot of these are really sweet features. How do they like count against like your budgets for tokens and all that?
Totally. It depends on, the general rule is they will. The models that are used though for a lot of these, the small ones are usually counting towards like your GPT-4.1 versus like right now I have Opus 4.5, which is using like 3 times my premium tokens. A lot of these models are configurable for the feature that you're choosing. And then also a lot of those low ones are actually using kind of smaller models like 4.1, ones that are a little more antiquated that don't use quite the premium request. So they do still count against. I don't find that they count against significantly. It's kind of like when you use an actual GitHub and you say, hey, coding agent, go at it. It's going to work for like 20 minutes, and it actually uses only 1 premium request over that entire time. So I find it doesn't use a ton of my premium requests. That's usually what I find is my limiting factor, not just tokens, but it is still using them. There's some configuration, some of those like the adaptive paste. I don't know if they have a model control for like that one specifically of which model are you using, but any other questions? Great question. How much time we got? Okay, I'm not going to go too far into these. We're now to like the big wow. You could go find this on the front marketing pages side of things, but these are the big agent capabilities that Copilot now has in Visual Studio. Debugger we just showed, that's coming from the unit test side, but you can also get that natively inside your solution using the @ symbol. So if I use the @ symbol, I'll get kind of all the things I'm showing to me, which is kind of, I don't know the right way to, they're different agents, but it's almost like the personality of your Copilot that you're wanting in that moment. Am I wanting the debugger personality for my Copilot, or am I wanting the profiler or the test? And obviously those all have strengths and weaknesses too with them. I'm probably not going to go ask the profiler one to go write me some unit tests because it's just not its capability. Just like I won't ask a backend engineer to go write me some, to go center a div, because it just will never happen. So these are kind of the overall coding agents that are now available. We have, still on the zoom it. We have debugger and profiler, test, modernize, GitHub. The GitHub one, I'm kind of just going to scratch that out for now because I think it's the least impressive out of the four. Debugger, starting there, I think that's really awesome. I can now ask it, so I can say at debugger, let's go solve whatever problem I have. Something's going on weird. Can you take the breakpoints, set them for me, figure this out for me? The profiler, I actually have started using even today. I have a quick extensions class. I find that very often I am going and writing where not null. That's just like I'm writing that link statement all the time. And there's a bunch of different ways to do it. I could do where.select. There's a whole slew of ways I could do this. So I wrote one naive approach, and I'm just like, maybe this is how I can do it, wrapped it up. And I'm personally not an expert at profiling methods. But GitHub Copilot, by using the profiler, so if I do at profiler, I apologize, the text there is even bigger than when I start typing, but something's weird there. I can say, hey, profiler, could you go analyze this piece of code? And what it'll actually go do for me is go so far as to go write me benchmarks to know where its starting place is. Using benchmark.net, it'll go write benchmarks to know what's the efficiency or memory usage and the speed of your extension method that we're trying to optimize. It'll actually go and run, if I can find where it stuck it. There we go. It'll actually go run a profiler against it as it's running it. And then it's going to go try to make helpful improvements. Obviously, this is a very localized example. I'm saying one function as like a one-line call, but you can actually go send this across your app. Earlier today, even, I was working with someone who said, our Grafana dashboards are saying we have really high memory usage on our application. What is going on? And all of us are like looking at each other. We're like, I don't know totally how to figure that on the fly. I see it says high memory. I don't know what's causing it. And we're able to throw Profiler to try to give us some insight as to what is happening there. I think this is a more niche one, but really useful one in terms of actually improving performance, reducing memory. I also heard another person who went to a company and said they talked about this profiler. The company went and used the profiler, like just a couple devs went and played with it, and they're like, oh yeah, within a couple days, we knocked out like 30% of our memory usage over that period of time. I'm like, that seems really significant for kind of an aside. So, profiler. We got the test one. Don't think this needs illustration, but as you can expect, this is just more in tune with your C# code. It is now going to go create your full-fledged tests, and I think the tweaks in here aren't brand new. They're just more tightly integrated in the ability to run and actually test what it's writing and iterate on these quicker. Once again, as you can't tell, I have my favorites, which are profiler and then modernize. So modernize is kind of the last one that I kind of want to cover here. I've found that Copilot is really good at upgrading my .NET application when it's simple. I'm usually fairly good about kind of keeping on the bleeding edge, so I'm like, hey, upgrade from .NET 9 to .NET 10. And it's like, I know how to do that. I change the numbers 9 to the number 10, upgrade some NuGet packages, and then you're good to go. Nothing's breaking, it just works. Unfortunately, every once in a while, we run into some applications that are a little bit older than .NET 9. And in those cases, there is a mode called @modernize. And let's say let's modernize this application to .NET 10. Let's actually go do this on a different application. Let's use this one. It's fantastic. Let's modernize this application .NET 10 and C# 14 using all the latest things. And this is a much more intensive process. And what I mean by that is not just going to go change the numbers and just be like 10, 10, 10, latest versions, have at it. It's going to actually go analyze your entire project. So it's a lot more optimized for old and legacy repositories. And it's going to create an entire plan. So it's going to create even a markdown file if you'd like. And then it's going to actually iterate and go start executing that plan step by step of your different projects that are in your solution in order to get everything up to the version you want. It's also even using NuGet, the NuGet tooling built in. And it's not just like going and querying the NuGet website. It's actually able to use some intelligence to say, oh, this is the versions that are compatible with my different projects, and making sure that I'm not just revving things arbitrarily and having conflicts. It actually has NuGet, the NuGet tool built in. You can see that down in here in the NuGet part, where it's actually able to tightly integrate that. So Ilgo tried to discover your upgrade scenarios. It's actually really good about prompting you kind of down the pathways. I don't know if it'll finish in time for this case. But it'll go prompt you down the upgrade scenarios where it says, oh, do you want to first, before we go, just upgrade .NET 10? Do you want me to go check out the NuGet packages as well? Or those kinds of things. So that's modernized. I found for larger code bases, especially ones that are multiple iterations behind, this is kind of the way to go when it's not as simple as just bump version numbers and you're off and running. Yeah?
Have you ever unleashed this on an old Angular project?
I've not unleashed this on an old Angular project. Let me know how it goes though. So I have tried this on like legacy, like pre.NET Core projects, and I took one just off GitHub that I found. I just used some GitHub query syntax and said, have at it, and it did fairly well at getting that up to latest and greatest from what I could tell. It wasn't my code base, so I'm not an expert of all of what it should do, but everything compiled, and I figured that's pretty good. It's a good start. Yeah, so yeah, that's kind of the features of Modernize. Once again, I could talk like an hour about each one of these, and there's lots of nuances when it comes to each one of these Copilot capabilities, but that's what we have there. So all in all, those are kind of the main personalities. So that I kind of like that word now that I've come up with it. The main personalities of Copilot that are now integrated into Visual Studio. So you have the debugger, actually able to kind of work through the debugging sessions as you might. You have the profiler that's actually able to analyze your CPU usage and memory allocations, surface performance bottleneck. It's actually able to create benchmark.NET projects. I've run into this where I go, we clearly have a problem around here, but that code's so tightly integrated into our entire thing that creating a benchmark.NET project around that just seems like a pain. It's almost easier for me to just copy out that code and start rewriting the entire stack up to explain it. Having AI do it for me, lovely. And then we have the test one. No, I don't think that's crazy new. It's just more tightly integrated and modernized, and then GitHub. That all to say, I have moved more towards using Visual Studio 2026 just because of the tighter integration with C# specifically. VS Code, great, but because Visual Studio is very built for C++ and C#, it's able to have a lot of the intelligence and smarts that I maybe wouldn't be able to get in VS Code. Those integrations of like, my breakpoint isn't set, can I use Copilot to go figure that out, and it knows C# syntax enough to do that? Or let me go explore exceptions and I have the intelligence to do that. So features are a lot more tightly coupled in a way that you can't maybe do with just the extension onto VS Code. So, questions, yeah? With, say that again?
Can you add more modes yourself as a VS Extensibility developer?
So, Kevin, correct me if I'm wrong, but VS Code you can. In Visual Studio, I've not experienced a way to be able to add different agents. So on VS Code, you can add your own custom agents. And so basically when you hit your, where's the, oh, we're now down. Yeah, I was about to say we're not in the right thing. Here we go. So when you have ask an agent on VS Code, you can add your own custom one that says, now you're the researcher from your example. And you're allowed these tools, and these are your instructions. That has not moved its way over to Visual Studio from what I found yet. I find that they're catching up, so I'm hopeful. We also found recently that Visual Studio is, as of last week, uses less memory on my machine than Visual Studio Code. So that seems like a feat. and I don't know what they're doing with the Copilot extension, but I have 6 Visual Studio instances open right now, and I think it's like 3rd or 4th down below Chrome on my task manager. So we're doing pretty well. That's true. I don't know. So right now I'm counting maybe 3 gigs across my, I mean, you can count 6 instances of Visual Studio. So fairly, it's a lot more lightweight than I found it was in the past, where I can only open up 2 instances and that's it. Yeah. Any other questions? So that's kind of the high level. We went 100 miles an hour. I hope that some of those things are nuggets that you can pull out and start diving in deeper on. But any other questions? Visual Studio 2026 features. Hopefully you're all convinced to go install it. Go install Insiders if you want the extra cool features. But with that, thank you all.
Yeah, take down your 47 screens you have going up here.
I know.
Well, that was a lot of cool stuff. I honestly was kind of disappointed when I saw 2020. It's like, oh, we got a new version of Visual Studio. It's just going to be more bloated than the last. And I've been pleasantly surprised. I gotta
It's so
say.
lightweight.
It feels lighter weight. It feels like it's doing more things. And it feels like, for a while, I felt like, look, I can pay a bunch of money and get Visual Studio, the real one, or I can for free get VS Code, which is better. And it's like, what's going on? And I feel like now they're actually kind of delivering on, hey, you're paying money for this thing, you should get a premium experience. And so it's kind of cool that they, even though it did take them a number of years to get there, I'm glad we've kind of arrived at what seems like a significantly better spot. So.
And I feel like I was forcing myself over to VS Codes, anticipating that was the future for a while.
Me too.
And I was like, okay, I got it. When I taught class and stuff, I was like, you can use Visual Studio, but
if you're
like
a real coder, you're going to be over here.
You might be here in 5 years, and this feels like a step back where I'm like, actually, we're going to play in the Visual Studio.
I missed the last part. Do they actually have good TypeScript support yet? Oh, no, they don't.
Am I going to ask? Why would I show that? It's .NET Conf.
Yeah,
we don't mention TypeScript. We don't mention Python.
But we do mention.
What about Razor syntax? Visual Studio?
Yeah, Razor syntax or Vue or have add-ins or anything like that.
Razor syntax has some improvements that came.
Okay. Anyway. Well, hey, thank you all for coming. Thanks for participating and asking fantastic questions. Oftentimes we do these and everybody just kind of looks at you and it's like, oh, when is it going to be over? The answer is soon. I think. That's right. There's just 3 more nights before we have dinner. So anyway, yeah, thank you for coming. Just a little bit more about IntelliTect. One of the things that we do here is our purpose, our mission is to alleviate global poverty, injustice, and suffering. And so one of the things that we do is you're not going to see a whole bunch of like huge mansions and super fast race cars and all that kind of stuff, but it's really about both here in Spokane in the United States, but really a lot of it is in Africa. And that's one of the reasons Benjamin was over there, was to see people move from a place of poverty to a place of not poverty. And it's been pretty cool. There's a bunch of cool groups like Capable and some places like that. And just seeing literally tens of thousands of folks because a lot of the efforts of the people here do that. So it's neat to be part of an organization like that, and we're glad to have you all kind of be a part of that for a day and kind of brush up against that. So anyway, please let us know if you have any questions. Great to have you here, and you'll just go up the stairs and kind of out the same way that you got in here. So with that, thanks again.